Good afternoon, everybody, real and imagined, to the AI Deep Tech stage. How are we doing? Yes? Oh, some responses. Excellent. I never try and do interactivity before someone's had lunch in them, because there's nothing worse than someone saying, do something that requires some mental attention, and your tummy is going, nope, and your brain's saying, no, I have not had enough to drink, I have not had enough to eat, but now I hope you have. I've had an incredibly large bowl of noodles, but I forgot to get chopsticks, so I've been backstage eating them with 2 coffee stirrers, which is the idea of innovation. You make do, don't you? And that's exactly what AI appears to be, this sort of Wild West of trying to do our best in an ever-changing world. So I want to start by saying thank you to your audience, all of you, for coming, and thank you also to Stability AI and the other partners who are here supporting us. Thank you. Okay, well, those of you in the know, or at least those of you with the app, will know that it's time for the AI applied block of the day. And that's where we're going to see machine learning making quite the impact on our lives. And we've got a series of talks now from various sectors. And in 25 minutes at around 2:45, DeepMind will be unveiling what's been going on in their collective consciousness. But first, please join me, rather, in giving a post-lunch welcome to Shell's GM of Artificial Intelligence. It's Amy Challen.
I don't think I've ever had walk-on music before, so that's nice. Hello, everyone. Thank you for coming. I'm the GM Artificial Intelligence in Shell, so I'm the global head.
Excuse me. I'd like to interrupt this talk to note that CogX here has invited Shell as a speaker, and also Shell is a massive sponsor of this conference. But you know what else Shell is a sponsor of?
There. Excuse me. I'd just like everybody to respect the other guests that are here at the event. Thank you very much.
Unfortunately, Shell has been sponsoring new oil and gas fields when the science is clear that we cannot have any more new oil and gas.
Okay, please can we respect the other guests at the event? Thank you.
Shell is complicit and CogX is complicit in the climate catastrophe.
Thank you. Global head of AI at Shell. So I work across all of Shell's businesses and functions to develop and deliver AI solutions, and that includes all sorts of machine learning, specifically natural language processing and computer vision. So I'd have some ideas I wanted to share about AI in the energy transition, and hopefully have a few ideas at the end for the questions, maybe, but we'll see. I'll leave the bots to read this one and summarize it for you. So I think, well, why is Shell interested in this? It's because I think that AI and digital have a really fundamental role to play in the energy transition. And there are 4 main ways that it has an impact. AI. Firstly, in efficiency. And I think this is a really underplayed aspect of energy transition. But just by doing nothing else but minimizing the impact of what we're currently doing, in improving efficiency, we can have quite a substantial impact on our carbon footprint. And I'll give you a concrete example of this in a minute. Secondly, by enabling a future energy mix. At the moment, the majority of our energy in many cases is provided through burning hydrocarbons whenever we want them. It's entirely demand-led. But when we have intermittent sources of energy, such as solar and wind, we're going to have to look much more carefully about supply and demand balance. And we'll have to have a demand response as well. So looking at that really carefully will be something that AI is very, very good at. And again, I'll give you some examples of how that works. Thirdly, in R&D and planning. So there's a lot of adequate solutions out there now, but there's much more scientific research that needs to happen to make the energy transition affordable and fast. And research takes time. If we can do anything to speed this up, it will help. And so there are a number of ways, both in the actual empirical sciences and in just planning all sorts of things, wind farms, installations of all kinds, that AI plays a role. And finally, in measuring progress, particularly looking at things like unstructured data, using computer vision on imaging and natural language processing on text, we find other more interesting ways, innovative ways of measuring progress and find out what's really going on, because it is a really complex picture and we need to know what's going on. So, to start off with energy efficiency, to give you an example of this. Again, I'd like to stress, I think it's a really big driver, but it's often a neglected one in the public imagination. And here's a quote from the International Energy Agency. Now, they tend to specialize in this, so I don't want to say it's the only view out there. But nevertheless, we should really take this seriously as one thing we can do now to speed the energy transition without any other changes. And they say energy efficiency is called the first fuel in clean energy transitions, as it provides some of the quickest and most cost-effective CO2 mitigation options while lowering energy bills and strengthening energy security. It's the single largest measure to avoid energy demand and net zero emissions by 2050 scenario. Again, this is one view, but I do think it's something we should look more at. An example of one of these pieces we've looked at in Shell is in a liquefied natural gas plant. We've used real-time optimization of the functioning there, resulting in a 2% production increase. So that means that you've got more energy out of that for less inputs. And particularly important here is that you can reduce the CO2 impact of that energy. And the equivalence of this, given that particular plant, is about the equivalent of about taking 28,000 cars off US roads for a year. Now, if you think of the kind of public transport or other implications of trying to get to that, the electrification of cars, the kind of infrastructure you need to put in to get 28,000 cars off US roads, it would be huge. But you can do this just by looking at some of our really large industrial installations and doing it. So it's something which is really worth looking at. There are other examples of this too. We can think about lubricant formulation, how you get the same output but with lower CO2. Looking at inventory optimization, again, much neglected sometimes, but again, you just have lower wastage, you get more for less. But there's a lot you can do there. Secondly, we talked about the energy mix and about what we're going to do when we have both intermittency, lots of solar and wind, and we don't know when it's going to be windy and we don't know when it's going to be sunny. Not when we want it to be. And also when you've just got a much more complex mix of energy sources, because you're going to have perhaps biofuels, solar, wind, all making up a patchwork of what we actually need. And so there we need to think about, well, a couple of things that AI is really good at. Firstly, forecasting. Weather forecasting, energy forecasting, because weather doesn't one-to-one turn into energy production. And then you're looking at demand forecasting as well. What's the other side of the equation? What do we need there? And then what you need to do around prices to incentivize the right behavior and understand how flexible people are, how price sensitive people are when they get that. Then you look at batteries. Based on these forecasts, based on the optimization you've done, what do we do with our batteries? Do we expend energy now, or do we store it for later? And then how do these batteries work themselves? How do we optimize batteries, much like your iPhone stops charging at 2 a.m. and starts charging in at 6 in order to optimize its life? How do we do that better in order to make much better use of natural resources? These are all things that AI is great at, and it's something that's going to be absolutely fundamental to making the new system work. Thirdly, R&D and planning. So as I said, we've got a lot of scientific research that needs to get done. And we use this as a shortcut to experiments. At the simplest level, this can just be, I don't know how sort of organized your scientific research has always been, but when I was an academic, data was everywhere. People had their own labs. You couldn't find something from 10 years ago. Putting it all together, extrapolating, and so you can extrapolating out from previous experimental data, it means you don't have to do as many experiments. You know what you've already done, and you can predict which experiments you need to do and just shortcut the whole process. That's a fairly basic AI piece. But you can also use, I don't know if you've ever heard of ChatGPT. You can also use things like ChatGPT in things like generative AI for molecular design. You basically get it to generate, based on some rules, some candidate molecules, and then try these out. And that's a really interesting way of thinking a bit more creatively rather than testing the same set of molecules that you're always doing. Also, we use NLP, natural language processing, to search through patents, articles, previous reports, to find candidate molecules, to find candidate operating conditions that we might have overlooked, but might be really, really help us in our operations. And then that's just the real R&D part, but also just in the construction pieces. You can always improve the construction of a wind farm. We've been looking at how locating turbines differently can actually help optimize the output. And similarly in other kind of areas. And finally, we can talk about measuring progress. And I think in some areas, you can measure progress easily. There's a defined metric, you know what you're trying to do. But many areas of the world are hard to reach. There are many, for example, carbon credit schemes where no one's really sure what's going on. There's a great lack of trust in those. And so, interestingly, machine vision in particular, using satellite imagery or other places, can really help you monitor at a different level what's going on. And so we've used it for monitoring ecosystems, so you understand carbon credits, you understand ecosystem degradation. These are things you can look at and will massively decrease the cost of monitoring these things and increase trust. We also use computer vision to detect leaks. Unintended methane emissions can be a major contributor to our carbon footprint. And to the extent you can catch these as early as possible and prevent them, once you understand where they're likely to happen, this can be highly effective. So where are we at? I think we're much better than we were 5 years ago. We've got over 100 AI-powered applications in development and deployment. We've got over 4 trillion rows of sensor data in our data lake, and this number goes up every month, which is a very, very positive circle. And we've got over 17,000 pieces of equipment monitored by AI in our predictive maintenance program. That ties into what I mentioned about just energy efficiency and productive efficiency. It's one of our oldest programs, and it's going really well. We have a lot of people registered loyalty programs. We have 600 fully professional staff and a lot of DIY enthusiasts. And increasingly, a large number of our staff are equipped with AI devices of all kinds. So we're getting there, but there's still a long way to go. And we've been doing a lot in generative AI as well. But there are always blockers and real challenges in realizing impacts. Everyone can do a proof of concept and get very excited about it, but it can be really hard to actually realize value. And first to this is just we need process changes. Unless you actually embed what you're doing and change the way someone is doing a particular process, it's not going to go anywhere. So you have to really invest in change management and work with whatever business area you're talking to really make sure that the process has properly changed and we're actually impacting things. Secondly, you need some technology that scales. So we now have an infrastructure of different platforms we can use and different partners. But if you just try and do it all in a local development environment, that's never going to go anywhere. So we don't try and build our own platforms. We always partner. We're not going to try and reinvent the wheel there. But obviously, that's a non-trivial thing to get going. Fine, ethics and compliance. So the landscape is getting more and more complex. And with generative AI, we see some risks being introduced with that just because of people's naivety about these tools and about what they can do. So last year, we actually implemented an AI ethics policy, and we're incrementing that all the time and getting ready for the EU's AI Act as well. Because this is something which is, we should be doing this anyway. We should be thinking about, should we do this or not? But this is getting more and more difficult. And then in innovation horizon, it's very easy to just think about the problems we want to solve right now. But you also have to think about what we need to solve for 5, 10 years' time and make sure we're getting ready for that. So I'm going to stop there, but I think I have time for one question, or 2 questions maybe. Oh, sorry.
Fascinating talk. Thank you very much. I'm really curious to know how a big corporate like Shell manages the race of open source technology, moving far faster than any of us can possibly read and keep up with, and digitize your own corporate brain and turn that into a useful tool for all the employees.
Digitize the corporate brain. We haven't done that yet, but we're working on it. I think in terms of open source, we're strongly supportive of that. We actually have open sourced some of our own products, like particularly in the areas of, so we've got a collaboration with LF Energy, to make available the infrastructure that sits below, I said there was 4 trillion rows of data, the infrastructure that sits below that as a database model and make that available to everyone else because it's a really good way of structuring a database. And there's other examples like that where we've open sourced things. We're also a strong believer in using open source components in many of the models we build. the second part of the question was about what digitalizing the corporate mind. I mean, we're working on it. I think it's always a struggle in any organization to really get access to your knowledge. But particularly with the generative AI programs we've got and natural language processing, that is something we're working on very, very likely. And it's very, very important in the R&D space. Great. I think I've even gone over time, but... Oh, we've got 5 more minutes. That's all right then. Sorry, another question.
Really, thank you very much for sharing your figures. If Shell is using AI this extensively already, why are you not decarbonising faster? Just interested to understand what the challenges are.
So one thing I might have forgotten to say is AI is not the answer. The answer is physical and chemical technologies and a massive shift in the way we do things. But AI is a massive enabler. So I don't think you could make, to my point number 2, about making a complex mix of energy sources work. I don't think you can make that work without AI. But it's not the foundation of it. Just with the AI, and as I said in terms of process changes and scaling, if you just have the AI and none of the embedding in business processes, none of the rest of it, it doesn't work. So I think it's a huge societal change that you have to get right. Now, I'm not an expert on politics, and I'm not an expert on the rest of it. I would like it to happen faster, and AI is a big enabler for that. And I spend most of my time working on that. But yeah, it can help it become faster, but it's not the only factor.
Interested in, as a part of this transition, what are the biggest skills that you see you need to develop across the organization over the coming years?
In the energy transition?
Yes, like skills for the employees across the organization.
Yeah. So I think in Shell in particular, it is going to be about the ability to adapt and learn new sets of skills. But I think that's universal. I don't think the jobs we have today are going to be the same in 20 years' time. I don't think that's a bad thing. I think lots of people want to change jobs. I think we just need to be very careful about the speed of transition for that, because we don't want to leave communities or groups of people behind. So I think actually in terms of, one of the big fears about generative AI is, are we all out of a job? And I don't think so. We might be out of this job, but we won't be out of a different job. So I think the big challenge for very large corporates is there's something about a place like Shell where many people work there for 20 or 30 years. You can get very comfortable knowing what your job is and knowing what you're doing. And we need to react faster, and we all need to learn new skills throughout the rest of our lives. So I think that'll be a major challenge for many of us. Even those of us who think we like learning, it's easy to get comfortable. And so I'm always looking, what next? So, I think there's
Hi. What's the most valuable source of data that you have for building proprietary AI systems within Shell?
I'd say it's the data we have which is genuinely core to what we do. And what we do is energy production, processing, and distribution. And so anything that's really core to that is core IP and is something that other people can't get. So I think in, for instance, catalysis. In our catalysts, tens of years of R&D data about developing new catalysts. This is absolutely core IP. So I think in that kind of area, particularly in R&D and production, that's key. And at the other end, customer, because again, having a strong customer base is there. And those are pieces where you've got to think very carefully about how close you hold that and who you work with, because it's core to what you do. Whereas, for instance, I don't know, Outlook, we're not going to build another Outlook. It's commoditized. Our finance systems aren't that interesting. Well, not to me. It's less interesting.
Hi. So I was curious to know more about the data landscape that we have at Shell. You mentioned that we have 4 trillion rows of data. I think that's amazing. And yeah, where were we 5 years ago? Where are we going to end up in the future? And what that timeline kind of looks like?
I haven't checked the 4 trillion myself, but I'm told it's there. I think 5 years ago, we had, as I understand it, we would have had a version of the data lake, but maybe not its current version. And it would have been tens of thousands, maybe, rather than where we're at. And that, as I said, that number goes up every month. and it's gone up a lot in the past year. In terms of where we are in 5 years' time, I think it's going to be really interesting because the structured data lakes are going to be really important. But what I find really nice about generative AI is it actually enables you to use unstructured data in a much more flexible way. And so we're experimenting with how you bring together repositories of text, image, and structured data to answer questions in a way we never have before. So I'm not saying we're going to abandon structured databases. They're incredibly important. But I think we're going to be able to be more flexible at how we set up our data because we'll be able to interrogate it in a more flexible way. That's what I think. I don't know.
Going to grow even faster. Thank you.
Thank you so much for your talk, by the way. And I'm sorry if because I missed it in the beginning of the talk. And I was wondering if your company or your department is working on like training or developing your own like language model or like LLM or NLP or something, or are you working with other companies or something? Yep, thanks.
Yes to both. I mean, we've got a generative AI program. We are working closely. We have a long-standing partnership with Microsoft through whom we get the OpenAI APIs, but we also work with other models, open source models, and other companies. And we're considering the options in terms of training or building our own models rather than just fine-tuning others off the shelf. It's difficult because the models you get nowadays are so good that it can be difficult to see a case where you would, but there are some really core IP cases where we would do that. But great. I think we're out of time, but thank you very much for your time. And I hope you enjoy the afternoon.
Thank you. Thank you very much, Amy Challen from Shell. Right, well, it's time for a quick 5-minute break. Coming up next, we have two powerful minds from DeepMind, that's Daniel and Andrea up here, transforming the foundations of practical computing in just a few minutes' time. See you in 5. Well, good afternoon once again, everybody. Those of you who are joining us for the first time, this is the AI and Deep Tech stage. Those of you who have been here a little while, you're going to know that already. I hope you're doing well, managing to train your brain on the vast amounts of data that we're giving you today. I'm LJ Rich, your host here, friendly and ready to help you through the AI and Deep Tech stage. Now, coming up at 3:15, we've got a fast-paced talk from William Tunstall-Bordeaux on language and intelligence. Yes, language and intelligence, two things that get progressively harder to access the later it gets. Right, next up though, we have two speakers for you, great value. Yes, in a brilliant 2-for-1 deal, it gives me great pleasure to introduce from DeepMind, staff research scientist Daniel Mankiewicz and senior research engineer Andrea Michi. Daniel's going to come on first and do a thing, and then he's going to introduce the next one as well. So sit back, relax, enjoy, and I'll see you after this.
Great. Hi, everybody. Very excited today to talk to you about how we can use AI to transform the foundations of practical computing. So, So we live in an increasingly digital society where we have more apps, more systems, more screens. We also now have the wave of generative AI, so people are training models, and all of this is creating an increase in demand for compute and therefore energy usage. Now, all of these apps, systems, models that are being trained are sending requests to lots of different types of data centers from many different types of companies, like the one seen on the left, where data centers can range from thousands to tens of thousands to maybe even hundreds of thousands of machines, all processing this information simultaneously. Now, the response from these machines will then go to our consumer devices, for example, where we're running software, like the code seen on the right. Both the machines and the data centers, the consumer devices are all running software. And underlying all of this is the hardware that ensures that everything's running and running efficiently. Now, chips are starting to approach their fundamental physical limits, and Moore's law is coming to an end. And we need to find new and innovative ways to optimize the computing stack. So we thought, let's start with the code. So we asked ourselves, what if we could automatically optimize the world's code using reinforcement learning, discovering faster and innovative algorithms along the way that we hope could benefit both practitioners in what they implement and researchers in how they approach developing algorithms. But in order to do this, we wanted to start with what code do we want to even do this in? And if we look at how most developers program, most of them will be programming in higher-level languages like C++. Then a compiler takes this higher-level language and compiles it down to a lower-level language called assembly, which is much closer to the CPU and interacts with memory and registers. And assembly is executed line by line. An assembler then takes this code and then turns it into machine code that can be executed on a machine. So we decided by starting to see, can we generate algorithms from scratch in assembly? And we believed that there were optimizations and discoveries that could be made in this language because it was more flexible and lower level than what we might find in higher level languages, such as C++. But in order to do this, we wanted to figure out what were fundamental algorithms that we could tackle first. So we're going to build these algorithms in assembly, but what is a fundamental algorithm that is called trillions of times every day and really underlies everything that we do in many of the applications that we use? And for this, we decided to start with sorting algorithms. Now, sorting dates back many centuries. You can take it back to the great Library of Alexandria, where scholars were sorting different books in the library. Then fast forward to the 1890s, where tabulation machines were counting and sorting votes. Today, sorting is found all over in all the different types of applications we use, from retrieving information and prioritizing what we see, to determining what jobs to schedule and prioritizing their ordering, to displaying information, as well as ranking the search results that you would see when using recommendation systems. We even see sorting algorithms as being very prevalent in string processing. So now that we knew that we wanted to build algorithms from scratch in assembly, and specifically sorting algorithms, how do we get a reinforcement learning system to do so? So what we do is we devise a game, and we call this the assembly game. Now, the way this works is there's a player in the game. The player here is our system, AlphaDev. Now, the goal of the game is for AlphaDev to find a sorting algorithm that is both correct and fast, ideally faster than the state of the art. Now, the way this works, if you look at figure A, is AlphaDev takes in the state, which comprises the algorithm that it's currently building, as well as the state of memory and registers on the CPU. It then plays a move in this game, which is choosing an assembly instruction to add to the algorithm that it's building. Now, we have to reward or penalize AlphaDev for adding this instruction. So what we do is then we check the correctness and speed of the algorithm. For correctness, what we do in the case of sorting is you feed in a set of unsorted sequences into the algorithm. Then, based on the outputs, if it's sorting correctly, you reward the agent. If it's sorting incorrectly, you penalize it. And then you reward it for making the latency as smaller and smaller. But how do we measure latency? This is one of the very difficult problems that we ran into, because the types of algorithms that we were building were sorting small numbers of elements, like sorting 3 elements or 4 or 5 elements, and we had to be able to measure latency on the order of nanoseconds. So what we decided to do was build what we called a latency benchmarking service. So while AlphaDev was playing the game, we had a set of additional machines that were put on the side, and every time AlphaDev generated a new algorithm, or even a partial algorithm, that we wanted to test, we would send it to this benchmarking service. It would then compute the latency tens of thousands of times across multiple different machines. And then using various statistical tests, we were able to generate a single number that reduced significant amounts of noise and allowed us to generate latency on the order of nanoseconds. And we have an error. This was planned, of course. You know, so it's going to be an error, and then we go back. And oh, yeah, yeah. Perfect. Yeah, sure. Any questions so far? Yeah, go for it. Yeah, great question. So the question was, do we think Moore's law is actually ending, or with things like quantum computing, do we think that we could just continue this trend? And I think it's a great question. I think Moore's law, in the current setup that we're in, with the current technology we have available, there's an argument that it is plateauing. But the hope is that we can come with new and innovative techniques. Quantum computing might be one. Our argument is that AI can also be used to find new and better designs, which Andrea will talk about later, that might help address that and increase the trend. And we're good to go. Great, cool. So, how hard is? Oh, okay, we were good to go. Any more questions? Oh, does it keep? Oh, okay. All right, great. So I'll talk about that slide. So what you would have seen on that slide is essentially just basically branching out of all the types of decisions that need to be made. Every time you make a decision of adding an instruction, there are so many more kinds of instructions that could be selected at the next step, and then at the next step, and you have this branching factor. And this makes the assembly game incredibly hard. And the reason for, and if we look at the total number of combinations of algorithms that that AlphaDev has to search through, this is on the order of the number of atoms in the universe. And so we need to have a really efficient way of being able to sort through this incredibly large space. So now, AlphaDev, our agent, had two key qualities. So firstly, it was built on top of this AlphaZero technology, but we needed to adapt this to the assembly setup. The first thing we did, which you see on this slide, is we had to create a representation that enabled AlphaDev to be able to understand exactly what the structure is of the assembly programs it's building and how these programs affect the dynamics of memory and registers. So this was the first part. The second part was the latency aspect. So we needed to enable it to be able to predict the future latency of a program. So this would mean that you could take on a partial program and then have a prediction of what it thinks the latency is going to be by the time you finish building the program. And this allowed us to compute latency much more efficiently. So with these two aspects, we said, well, let's go. Let's start tackling one of these big sorting functions. And there are fundamental sorting functions out there, like, for example, sorting 3 elements or 4 or 5 elements. And what happens is when you call very large sorting functions, like sorting 1,000 elements, it calls these fundamental functions repeatedly. So the hope is that by improving these lower level, smaller fundamental functions, we can have this effect of improving all sort functions. So we then ran it, and we said, let's see if we can do something with sort 3. It's a really highly optimized function. Is there anything we can discover? And on the left is the sort 3 function that AlphaDev generated from scratch. And what was remarkable for us at the time was that it managed to find an algorithm that was 1 instruction shorter than what currently existed. And we analyzed this for ages, and we were like, there was nothing that you could do to make this faster. But it managed to find something that was 1 instruction shorter. In addition to that, on the right-hand side, we also tackled what's called variable sorting algorithms that could sort up to 4 elements. And this is a function that AlphaDev generated also from scratch. But here what's unique is that it had to do things like branching and determine when it had to switch to a completely different part of the program. And sometimes it hadn't even written that program yet, so it had to understand that it was going to write that program. So there were a lot of these very difficult, complex dynamics that AlphaDev had to try and understand. So we managed to get good results for sort 3, and for sort 5, we managed to reduce it by 3 instructions. And we said, let's try and see whether we can make this available to the world. But to do so, we would have to get these algorithms into an open source C++ standard library where these functions hadn't been updated in over a decade. So we submitted them and went through a process and managed to get it accepted. We managed to get improvements for sorting 5 elements of up to 70%. And we managed to get improvements on over 250,000 elements being sorted of around 2%. In addition to this, we estimate that our functions today are being called trillions of times every day. And there's a corresponding Nature paper that you can check out if you'd like to get more information. So I mentioned earlier, or right at the beginning of the talk, that we wanted to be able to discover faster algorithms, and this is something that we were able to do, but we also want to discover fundamentally different algorithms. Now, if you look here, this is variable sort 4, and on the left-hand side in figure A is what the human benchmark is, or the standard. If you send in, for example, 4 elements, so here the numbers are 8, 6, 7, and 2, the way the algorithm currently works is if it sees that the vector has 4 elements, it calls sort 4 to sort 4 elements. If you send in a vector of 3 elements, it calls sort 3, and similarly for a vector of 2 elements. Now, on the right-hand side is the variable sort algorithm discovered by AlphaDev. And it works in a very different but quite intuitive way, in that given the same 4 elements, it first checks, well, are there 2 elements? And if it was a vector of 2 elements, it would call sort 2, and you were done. But if there were more than 2 elements, in this case there were 4, it immediately calls sort 3. And then it says, well, was it actually a vector of 3 elements? And In this case, it's not, but if it was, it would call sort 3, and we were done. And then, at the end, it calls a much more simplified algorithm for sorting 4 elements, because already 3 of the elements have been sorted. And it's this aspect of the algorithm that allows us to get significant improvements in both latency and in the length of the program. And so we really think that there is this potential to be able to discover fundamentally different algorithms that can really benefit both researchers and practitioners. So we're now moving on from sorting to hashing to the rest of the computing stack, and Andrea is going to take you through that. So thank you very much, everyone.
Thank you, Dan. So the question now is, can we use AlphaDev to generalize to algorithms beyond sorting? So what we did is we took AlphaDev and we tried it on another fundamental hashing algorithm, hashing. Hashing is an algorithm that was invented more than 70 years ago by Peter Hanslow with a very clever idea of bucketizing information to speed up search. So very similar to the image on the top, we often start with a string, we apply what we call a hash function, and that gives a hash. You can think of a hash as a location in a storage. Similar to how a librarian could take a book, and based on the name and the artist and maybe the genre, is going to find the position of the book in the library. That as well is a hashing function. So we decided to try AlphaDev in this algorithm, which is pretty much fundamental in all information retrieval systems, but also, of course, as part of common data structures like hash maps. And we applied exactly on a hash map, which is the one in the Abseil open source library in C++. And we were able to discover a faster hashing function, specifically from 9 to 16 bytes, where we replaced 2 multiplication with a single multiplication and a rotation. And this difference in the algorithm provides similar benefits in terms of quality, but a much speed up in terms of latency, and a reduction of about 30%. I'm happy to say that this was released in the Abseil open source library, so it's now accessible to all C++ out there, of course. And we conservatively estimated that it's being called more than 1 trillion times per day. So if we take a step back, though, we spent a bit of time thinking, where can we use AlphaDev? What type of algorithms can we optimize? And we came up with 2 criteria. The first one is we can either do exhaustive search when we search for the input and outputs. So what do I mean by that? When we discover these algorithms, we need to make sure that they're functionally correct. And there are not many ways to get around that. So for the case of smooth sort, what we are doing is we try the algorithm on every permutations of those numbers. That, of course, doesn't scale. It doesn't scale to large sort, right? So if that condition is not met, for instance, it's not met for hashing, right? We cannot possibly test the hashing algorithm on every string out there. It's not going to scale. If that condition is not met, though, what we can do is, if we don't need the functional correctness, it's good if we just have a measure of quality. And we have that for hashing. What we do is we take an input distribution of strings, and we measure the quality of the hashing, so things like number of collision or the entropy of the output distribution. And we are lucky, though, that there are quite a lot of algorithms that fit one of these 2 criteria. Things like JPEG compression, so to compress your images, or things like serialization, like protocol buffer, how do we transfer data across internet, or crypto hashing as well, and so on. But zooming out from algorithms optimization and looking at the entire computing stack, the computing stack is made by many complex layers, and the problem starts much earlier on. It starts at the data center level. There you have a very large number of machines, and a common problem is how do we schedule workloads and jobs, and which machine do we run? Then after we go from the data centers, there is the problem of transferring the data up to your device in a cost-effective way, but still maintaining the quality, like the problem of video compression. Then, of course, there is the problem of actually running the software and optimizing those algorithms, like we saw for the case of AlphaDev. And finally, the hardware problem. Can we do something to optimize hardware? So starting from resource scheduling, if you look at a particular data center, there you have a very large number of machines. And each machine has different properties, like different values of CPUs, GPUs, RAM. And we need to schedule jobs, and each job has different requirements. So if you want to run a website, for instance, you might need a little bit more CPU. Well, if you're trying to train the next language models, it's GPU the thing you want, right? So all these jobs have different requirements. And it really looks like a game of Tetris, multi-dimensional Tetris. And the problem here is that we want to allocate these resources in a smart way. Because, for instance, if we end up with a machine where we used all the CPUs, but we only have some RAM left, well, the RAM is not going to be used, right? It's wasted. We call it wasted resource. And that is exactly the same in Tetris. In Tetris, if you're left with an empty space and the line doesn't clear, well, it's bad, right? There's nothing you can do at that point. And similarly to Tetris, where planning is very important, it will be very valuable if you can predict what's coming next. And that is exactly what we do in this problem. Oh, so we don't have the slides again. Great. So, yeah, and if you imagine like a resource scheduling similar as a Tetris game, right? So where each job or workload that we're trying to schedule is a piece, what if you could predict what's coming next, right? What if you could tell, okay, maybe like the next job is a job that is going to require quite a lot of CPU? It turns out that we can, because we have access to all history of distribution of workloads, right? So when we train our agent, what we do is we give the history of the workloads of the past, and our agent becomes very good at predicting these patterns and at forecasting. And with that information, is able to leverage it and be able to come up with a smarter scheduling algorithms. And in live testing, so this is coming quite a bit later, so yes, we were here. So in live testing, what we are able to show is that we reduce by about 19% the amount of wasted space. And why is this important? It's important because it means we can do more with the hardware we have, which ultimately leads to a reduction in energy consumption. And taking to a step next, going from data center up to your device, how do we transfer data in a very efficient way, in a way that is cost-effective but still maintain the quality? For instance, the video compression problem. And why is video compression important? It's because nowadays, video streaming takes the majority of internet traffic. And be able to compress this video in an efficient way is fundamental. And there's been quite a lot of work over the years, decades actually, in coming up with efficient codecs like VP9s. So what we did is actually try to apply our agent to a VP9 codec and try to treat it as a game again. Here we're trying to set the quantization parameter. So it's a parameter that tells you the information that you want in each frame. And we treat it as, again, the wrong side, and we treat it as a sequential decision problem. So what does it mean? That we decide the quantization parameter on each single frame. And the intuition here is that not all frames are the same. So imagine you have a frame with an explosion or a car moving. Well, you really care about the information in that frame. But if it's a static image, maybe of a house, well, it doesn't matter as much, so you can probably compress a little bit more. So you can be a little bit clever on how you do these things. But the key idea, though, is that the way you encode a frame is going to affect every future frame. So here comes the planning aspect and the sequential decision processes, where a reinforcement learning is really good at. And in this problem, we were able to save about 4% bit rate while maintaining the same quality. And I'm happy to say that this agent based on Mute Zero is now live on YouTube, powering every YouTube video that you watch. So taking a final step, looking at the last layer, which is the hardware one. Is there anything we can do here? Well, it turns out we can, right? And as well, we treat this as a game. So what we do, we looked at small circuit designs, things like adders, multipliers. These are fundamental components of hardware designs. And putting them together, then it's how you build like larger hardware components. And we treat it as a game with the objective of maintaining the same functional correctness by minimizing the area or maybe improving the performance or reducing the latency. As recent as a month ago, we participated in a competition, IWLS, which is the International Workshop of Logic Synthesis, and our agent won the competition, generating a better design for about 83% of the problems. And I think in this space, there is a lot more we can do. So in conclusion, AlphaDev discovered faster sorting and hashing algorithms. Both of them have been deployed to open source libraries, so they're accessible to every C++ developer out there. And we estimated that they're being called about trillions times per day. But taking a step back and looking at the entire computing system, as our society is getting more and more reliant on computing power and on software, it's of paramount importance that we build solutions that can make this digital transition efficient, and sustainable. And I strongly believe that artificial intelligence can play a role in that solution. And this is why we're doing this work. And this brings the end of our presentation. It was a real pleasure to be here, and I'll be around if you want to chat, or feel free to reach out by email. Thank you very much.
Thank you. Thank you very much to one half of the hive mind of DeepMind there. Yes, I don't think there's a problem being assimilated with all that fantastic information. Right, what we're going to do in just a few minutes, none other than William Tunstall-Prideaux is going to be here with language and intelligence. It's thoroughly worth staying here for, and there's only going to be a 2 or 3 minute turnaround to stay to time. So if you like, you can chat to your neighbor. You can maybe ask them a question and see if they are using ChatGPT to answer or if they're actually giving you a proper answer. In the meantime, we'll see you in just a couple of minutes' time. Thank you. Oh, well, fancy seeing you here. We must stop meeting like this. Hi, I'm LJ Rich here, your host for this afternoon at the AI and DeepTech Summit here at CogX number 7. I hope you're holding up. It's an incredibly packed conference, isn't it? It does feel like you're just on the run, on the go all the time. And I'm really enjoying listening to everything today, and I hope you will too. Thank you very much to Stability AI and other partners for their support on this stage. And I'm LJ, your host. Pleasure to be absorbing all of this with you. And if you want to know what the future holds, then you know what? We can ask our next guest. Yes, don't just ask the machines, ask the expert who knows loads about them. You can also do that through the Slido app. I think we've managed to get that working. So if you head to Slido, I'm not sure if we've got the code. Oh, I think we have. Look at that, a giant QR code. You're going to have to take it on trust that that goes to the right place and not something that just automatically directs you to a book that you might wish to read that someone has decided to make a QR code of. I always see this. I was doing a cybersecurity conference a while ago, and I talked about the ease at which these things can be exploited at events. But anyway, please enjoy taking a picture of that and joining the questions here on Slido. I'd be really happy to ask our next guest some of your questions instead of mine. All right, so let's get ready for, what have I put here? CogX's answer to Only Connect. It's a talk on language and intelligence. I can't wait for this. It's from Unlikely AI's William Tunstall-Padot.
Hi. That slide moved without me pressing a button. That's very clever. It's lovely to be here. Just wanted to quickly introduce myself. So my name's William Tunstall-Padot. I run an AI startup in London. We are looking at safe and effective general intelligence, so very much adjacent to the theme that I'm talking about today. We're about 50 people, venture-backed. I'm best known, though, for my last startup, which was a 10-year entrepreneurial adventure. Another deep tech startup based in Cambridge got acquired by Amazon eventually after sort of 7 years of pivoting and various adventures, and we built Alexa with the tech know-how in that period. And I was there until 2016. So obviously that worked out quite well. Amazon sold hundreds of millions of devices. It's a brand everybody's heard of. Everybody's used it. And what I'm doing now is an attempt to build something even bigger than that. And I've also spent quite a lot of time mentoring startups as well. So I've got a lot of expertise, a lot of experience, kind of talking to people, the next generation of deep tech and AI startups. So the purpose of this talk is to try and frame what's happening in AI at the moment. As I'm sure you've noticed, AI has become very, very hot for about 9 months, since December at the end of last year. And I think it would be very useful to kind of frame it, to kind of give some definitions, to kind of explain why it's suddenly become so hot and why it's a moment in history at the moment with general intelligence. So you probably are familiar with these terms. They're thrown around a lot. AI is an extremely general term. It basically means making intelligent machines. And there's another term, machine learning, which people regard almost as synonymous with AI because it's used almost all the time in the same context. And that's because pretty much all of the AI that is done at the moment is machine learning. But machine learning means something quite separate. It means making machines learn, which is a distinct definition from AI. And within ML, it's a very specific type of algorithms that people spend almost all the time on, which is the statistical algorithms. They're essentially trying to learn weights in a formula. And of all the various machine learning algorithms, there's another term which we hear the whole time, which is deep learning, which is one specific machine learning algorithm, which is deep learning, very big neural nets. And neural nets have a key point I want to get across in this talk, is that deep learning has this magical property that it continues to improve the bigger the neural net and the more data you give it. And this is what has driven the advances in AI over the last 10 years. So the human race is generating larger and larger amounts of data. So one of the tailwinds for AI is more and more data is being produced. We all have smartphones. More and more people have smartphones. Those smartphones are getting faster and faster. So the amount of data that the human race is generating is exponentially growing. And most of the data that has been generated in the last 2 or 3 years. This slide is slightly out of date. All my data is just 2 or 3 years out of date, but the trend is absolutely the same. And the other really big trend that's driven, that's been driving AI is increases in compute. So remember I said that deep learning gets better the more and more data that's given, and the bigger and bigger it is. So the amount of compute that's available, raw computing power that the human race has also been exponentially growing, and it's been exponentially growing for like more than 100 years. So this slide goes right back through various generations of computing technology. The key thing to understand is that the y-axis here is logarithmic. So that supposedly slightly curved line is actually more than exponential. So the amount of compute and power that you can purchase for a fixed amount of currency has been growing exponentially for more than 100 years. So those tailwinds have also driven huge economic benefits to big tech companies. So in 2010, there was only one big tech company in the top biggest companies, which was Microsoft. And a decade later, all the biggest companies are big tech companies. So that those trends of data and compute and the capabilities that have come with more and more data and more compute have driven economic benefit to the big tech companies, with the result that we now have multiple trillion-dollar companies that are big tech. And this trend is continuing. OK, one more definition. General intelligence. So this is an ill-defined term. And historically, AGI was a slightly kind of off-the-beaten track, slightly niche term. It was the kind of the future, sci-fi future, the computers that you see in sci-fi. It's now become quite mainstream. But having said that, there's not a lot of consensus about what the definition is. So clearly, the human brain has it. Everybody would agree with that. It clearly does many different things with the same algorithm. And people have got different ideas about when AGI is here. Is it going to be solving big scientific problems? Is it going to be inventing things that can't be invented? Or is it just a general capability like we're already seeing with LLMs? Which brings me on to the next thing, which is large language models, which I'm sure is a term that everybody's heard of. These are big deep learning models that do one thing, which is predict the next word. So you give them text, and they predict the next word. And having predicted the next word, you can then ask them to predict the word after that. So by repeatedly predicting the next word, they can write. And these models, the latest large language models, are absolutely enormous. So they have hundreds of billions of weights in them. And they've been trained on tens of terabytes of data. So they've been trained on meaningful amounts of the text, of the language that's ever been written. And surprisingly, with these absolutely massive models, they've started to do these emergent things that surprised a lot of people. They've started to be able to sort of act intelligently, predict words in a way that is very difficult to understand and shows cleverness, shows intelligence. This is like a really simple example of an LLM. And as I say, all they're doing is continuing the text. So this is like 3 very simple examples. One is a creative example. Give us a slogan for a startup. The green text is the continuation. So the green text was generated by the model. The black text is what was typed in. Something very simple like sorting is an emergent capability of these models. And general knowledge. So having been trained on the raw internet, it can tell you about cheeses or any other general intelligence, general knowledge type question because it's kind of learned it from seeing it in the training data. And what happened in December last year was that OpenAI launched a consumer product, ChatGPT, which is just essentially an LLM. So it converses with you, but the way it generates its half of the conversation is just by continuing the text. It's got some other innovations in this as well, but very simply, it's an LLM. And it's also exhibited a little bit of a step change in capabilities, which took a lot of people by surprise. So the wave of, a big part of the wave of generative AI, a big part of the excitement that we've been seeing since December last year as a result of ChatGPT and its capabilities and its enormous adoption. So in just 2 months, ChatGPT got to 100 million users. That's faster than any other previous software product, which fully underlines the capabilities and excitement that the LLMs and these very large models have started to have. OK, so this brings me on to general intelligence and LLMs. And one of the key things I want to talk about today is how language can be the substrate for intelligence, and this is why LLMs are so exciting. Natural language can be used to express arbitrary problems. It can also be used to express solutions to problems. So if you create something that automatically goes from problem to solution in a general way, you've got the beginnings of general intelligence. And this is something that we haven't seen before. So often when you train a machine learning model, it's doing something very specific. You're giving it data, you're telling it to classify into 5 boxes. It's doing that. It's in a small vertical area. Because these things are trained on language, they're able to talk about everything that you and I can talk about, and they're able to generate responses and answers to absolutely everything. So this is like a moment in history, incredibly exciting. This is the beginnings of general intelligence. And as I said, AGI was previously a slightly crank, slightly edgy thing. For me, one of the biggest events in the last few months was this paper being published, which is published by Microsoft, so completely mainstream, completely respectable. This is a 150-page paper where they evaluated OpenAI's latest model, which is GPT-4, and over 150 pages concluded that it's showing the beginnings of AGI. Sparks of AGI is what they put it. So you could make the case that AGI is already here. I think when we look back in 10 years, I think we will look at GPT-4 or ChatGPT as the beginnings of AGI, beginnings of it arriving. Having said all that, this technology is not without very significant problems. So one of the problems it has, like all deep learning, is that it's virtually impossible to explain the results. As I said, when you create a deep learning model, you're creating a formula with hundreds of billions or even trillions of weights. Those weights are initialized randomly. They'll then got to their final values by exposing them to astronomical amounts of training data. The end result is a formula which has taken, where all the individual weights have taken weeks or months to get there. That's almost the definition of unexplainable, in my opinion. The people building them don't understand how they work. The models themselves certainly don't understand how they work, even though the LLMs will have a stab and confidently explain how they got there. They really don't know. Other problems include the fact that the data is often the raw internet, so it's exposed to all the biases and things that are wrong with the naked internet. Hallucination I'm going to talk about in a second. The other thing I mentioned in terms of confidence, so they generally always produce an answer. They almost never say, I don't know. They almost never qualify the answer. So when they're wrong, they say it confidently. They create answers that are plausible. And there's all sorts of short-term risks around their use as well. Intelligent spam, marketing, impersonation. So there was all sorts of concerns with this technology too. I want to talk about hallucination in particular because this is a particularly big one. So on the right here, you have a bio of me that was generated with ChatGPT. What's fascinating about this bio is that 40% of it is fiction. So 60% of it is accurate, 40% of it is completely and utterly wrong. But what's so fascinating is that I am probably the only person that could actually say which is true and which is false. Even close family, close colleagues would not be able to tell. The stuff that's been generated that's wrong is so plausible, it really would pass muster almost anywhere. It says, for example, I'm on the advisory board of the Centre for Computing History in Cambridge. I live in Cambridge. It's completely plausible. I will be helping them. I've got no contact with them whatsoever. It's given me two co-founders for my first business. I Googled them. They're real people. They're actually very plausible co-founders for my first business. I've not met them. And worse, it's actually given references for all of this. So all of these false statements have got a little reference. They've got URLs. They've got headings. It even said the data to access them. They look like incredibly plausible web pages. You click on them, they're 404s. They've never had any content on them, completely invented, hallucinated by the model. I have a background in question answering, in search, in the creation of Alexa. I know the worst possible user experience you can have is to answer a question in a way that the user believes where the answer is wrong. So if you say, I don't know, that's a bad experience. If you produce a completely dreadful answer, that's a really bad experience. but at least the user knows it's wrong. But if you tell the user that if you tell the user something's wrong that they believe that's plausible, they go away, the world is a worse place. These models do this almost by design. The other example, I've lost my slides, by the way. The other example, which just amused me, is ChatGPT creating a conspiracy theory for Building 7 of the World Trade Center that is completely novel. Not even the conspiracy theorists believe it. You know, was Building 7 demolished, or did it collapse in a fire? ChatGPT answers it was demolished, but it was demolished deliberately for health and safety reasons. I mean, it's like somewhere between the two worlds, completely novel. Anyway, because of all these problems, there's been all sorts of press about fears and risks. The risks that people talk about are everything from the mundane disinformation, etc., right through to the destruction of humanity. There's been if you've seen the headlines, there's all sorts of debate about it. It's a considerable concern. There've been talk of pausing AI. There's all sorts of talk about regulation. There's all sorts of pressure to discover solutions to these problems and to manage the coming wave. But I want to end on a positive note, which is the possible benefits of AGI. So, if we get it right, having machines that are very intelligent and can solve general problems and can solve problems in a way that's more effective than humans could creates absolutely enormous opportunities. So we're talking about curing disease. We're talking about advances in healthcare. We're talking about huge advances in productivity, so economic benefits flowing to everybody. This is if we get it right. Huge advantages in education. We're talking about everybody having their own assistant that can guide them, can help them, can give them the information they need, educate them, make them happier. So I actually want to defer to Mark Andreessen here because he wrote an extremely good essay on this. So he's actually more able to articulate it than me. So if you want to get a clear understanding of the positive case for AGI, that would be it. So that's what I had to say. I'll take questions now.
Thank you very much to you, William. And we've got some time for some questions, so please feel free to ask some questions on Slido. I do have one question just to start,
sure.
Which is, why and how did you calculate April the 11th, 1954 was the most boring day in history?
Okay, so that happened. Okay, that's a story from my first startup.
Uh-huh.
So my first startup, which eventually became Alexa, had technology that answered questions, understood natural language, could reason, and it had a huge database of the world. So it understood hundreds of millions of facts about the world. Mm-hmm. And by scanning that database of facts, we were able to work out what date was the least interesting, had the least happen. Mm-hmm. And it was April the 11th, 1954. We put out a press release. It was a fun thing. We had hundreds of thousands of articles in thousands of languages. And every April the 11th since, we've had further press for like 11 years. There was even a play was put on in Germany. Somebody actually created a play with that date. It was just like the most insane sort of viral PR thing that we did as our first startup. So it was a lot of fun.
Oh. Well, there you have it. Just choose a date and make that the national day of whatever's relevant.
Yeah, it wasn't made up. It was calculated. But but of course, the interesting thing is, having been the most boring day in history, it's now become a very interesting day because it's been designated as being the most boring day in history. So it almost became provably false the moment it was asserted.
Oh, that's kind of a very strange. The observation of it has changed its state. I had one of the very first Amazon Echoes, and I mean, for me, it was like the Star Trek.
Not as early as mine, but yeah.
Not as early as well. Clearly, I mean, you probably had one.
I was the first person in the UK to have one by about 2 years. Yeah.
Did you show it to people? Did they think
no,
you?
It was a secret prototype device, but
you just sat quietly and.
it kept going in a drawer whenever I had visitors and come out. But yeah.
So what was the point where you kind of accepted it as a general part of life? Because I think many people went through this phase where, I mean, for me, I did. I went round to someone else's house and they had one of these devices. And I heard my friend ask Alexa something. I said, what are you speaking? She's mine. What are you speaking to her for? And it was very weird how now that isn't the case.
It's really weird. It's like, so when I first was giving talks about it, I used to bring a device on stage and show people because I'd never seen it. And I used to ask people to put their hands up if they'd heard of it. And then there was a point, I don't know, a few years in when everybody had used one, everybody knew what it was, everybody had got one, and it became completely irrelevant to demo it. And that happened really quite quickly.
I think so. Yeah.
It's been quite weird. And then you sort of see the cultural references to it. You know, I'm watching a Hollywood film or something, and suddenly somebody will start talking to Alexa in the middle of a film, and it still surprises me to this day.
Yes. Well, yeah.
Something that you created has that kind of extremely wide impact.
Yeah.
You talk to people the other side of the world, they know about it. Yeah.
I think one thing that all of these devices do struggle a little with is that follow-up question, the context within which questions are asked. Do we have a time scale, do you think, as a kind of closing question on when we can see this happening?
Yeah, well, LLMs obviously are a step forward in natural language understanding and processing, and they can certainly do follow-ups with stuff put in the context. And Amazon's on record as working on integrating LLMs into Alexa. It's obviously, there's a lot of difficulties when you're putting something into production at that scale. You can create, obviously, you can play around with ChatGPT and see it doing stuff, but actually putting stuff into hundreds of millions of devices with a voice interface is potentially something that will take a while. But yeah, the technology is to create that step change improvement is already here.
And I think as language is evolving, I mean, generally we see new words being made up all the time. Can we see a future where the machines are starting to create their own taxonomy?
Yeah, one of the questions I asked ChatGPT is to coin a term for something that I need a term for. And it actually does quite a good job of that. So
it seems to be quite good at puns. A lot of these sort of models seem to be fine with that sort of thing. But I'm waiting for it to come out with a word that I don't know yet. And that's going to be really strange, but I think I might play with that. Oh my goodness, what a fantastic person to chat to. Everybody, it's William Tunstall-Beddoe. Thank you. Cool, that was fun, wasn't it? Look, if you want to, please join us again in 5 minutes' time. For those of you who want to go big, this is the place to be with scalable infrastructure. Afio Shaholo is coming up in just a tick. See you soon. Welcome, welcome back, everybody, to the AI and Tech Summit. And it's me again. Wow, would you look at that? Anyway, it's just a short talk for you this time. It's only 15 minutes, but I'm sure every single one of them will count. So I'm going to just bounce on and off stage rather quickly to maximize the time. Please, everybody, can you give a late afternoon, but still enthusiastic and energetic welcome to our next guest, who's no stranger to scale, a full stack 15 minutes from CloudFO and Onfido. It's Afia Chaholo.
Hello CogX. I hope everybody is doing well. My name is Afia Chaholo, and for the last 5 years, I've led on the development of Onfido's AI technology platform. And just a few weeks ago, I stepped away from my position there as a VP of Engineering and Technical Program Management to go on the crazy founder journey. Yes, I am now co-founder of CloudFO. And CloudFO is your AI finance colleague. And it's bringing the power of generative AI to company finances to provide true business intelligence. And today, I'll be pulling from both of those experiences as we discuss the integrity of infrastructure and systems in a scaled AI operation. Now, at CloudFO, we believe that in the future, we'll have colleagues that are human and colleagues that are AI. And just as we'd expect our human colleagues to act with integrity, we're going to hold our AI colleagues to the same standards. But that integrity needs to be intentionally designed into the systems as we build them. Now, if AI is the brain power, then integrity has to be built into it. So over this next 3 days of this incredible conference, you'll hear all about the latest in computer vision, natural language generation, neural networks, and it gets really exciting. But as I said, this has to be applied. So it's interesting when you add in the layers. Integrity is built up through the depth of the AI system. And it's complemented by our people, our processes, our policies, and how we execute. So let's start by framing the business problem. What are we trying to solve? Our technical actions need to be guided by the business goals. Our company vision, mission, and goals are measured by how well we meet our customer needs. And that measured by how well we meet our customer needs. And that not only frames our product definition, but also guides our operational frameworks. You see, everybody in the organization needs to internalize these goals and internalize the customer context so it can guide our technical decisions. Okay, let's get into some of these layers on the left-hand side, and I'm going to start with data first. You've likely heard phrases like, data is an asset, it's the new oil, and let me move back. It's the new oil, and garbage in, garbage out. Yet, there is actually a debate about what's more important, the model or the data. Now, let's simplify machine learning. You start with some data, you train and optimize a model on that data, and then you use that model to make predictions on new data. Yet, data preparation, data collection, exploration of features tends to be the less sexy part of the AI conversation. But data is so important to the integrity of an AI system. And it can be really challenging because data is messy, it's dynamic. And when it comes to preparation in terms of supervised learning, labeling can be resource intensive and expensive. So you can take a data-centric approach by spending more time exploring the data, getting your machine learning researchers and subject matter experts together to define patterns and functions within the data. Now, this can be then fed into an intermediate model that can be used to train the final model by labeling data and maybe even generating synthetic data. Whichever approach you take, data quality matters. That's accuracy, completeness, and consistency. We also need to address bias in data so we don't cause harm. And larger data sets don't guarantee diversity. we talk a lot about web-scale content in terms of training large language models, or LLMs. But did you know that most of the web content is dominated by English, and 75% of the global population doesn't speak English at all? And when you add the fact that tokenization varies across different languages, this further causes disparities. So we need to keep this in mind, but we also need to consider our data architecture. So storage, access patterns, pipelines, data leakage, and monitoring for bias, of course. Now, in this debate ongoing about what's more important, the data or the code, it's really interesting that some of the larger players have recently lifted the lid about what's going on underneath their models. But they've yet to do the same with their data sets. So we could argue that data is your competitive advantage, but in reality, it's a bit of a redundant debate, and we actually have to evolve both. Now, machine learning spans from classical tree-based models to complex layers of neural architectures. And in practice, companies employ many models, ensembles of models, and for various features. And then they have variants for different customer segments, users, and regions. And they're all constantly being updated. You'd probably say that your human colleagues are not very predictable, but we do expect a level of predictability from our algorithms and systems. So I've presented this slide as a simplified circuit loop for simplicity, but actually there's iterations on each step. I won't cover the data steps again, but just highlight some of the people involved, like data ops, data engineers, machine learning researchers and engineers, analysts, but also people from outside your technical org, like sales and subject matter experts. And together, they will need to define the features that will optimize the algorithm's performance. And if we're conducting prompt engineering, then we need to make sure we're building fair, ethical, and unbiased prompts. When it comes to integrity in model training and experimentation, we need to start with baselining our current capabilities, selecting the right model type. That could be something classical, or it could be something more complex, which is why we need to constantly assess our risks. So a medical use case or high-value transactions may require a much more complex, resource-intensive model. And of course, as we're experimenting, we have hypotheses to try and optimize for specific variables and parameters, but we have to monitor other factors like resource usage, compute, and speed, and if there are any signs of bias or harm. Now, when it comes to validation and evaluation, it's not just about the models, but it's also about our data splits and our entire process loop. Similarly, for model deployment, we have to think about versioning for our models, our data, and the artifacts that we produce. And make sure we have robust monitoring and tracking of the variables and the models in production so that we have model reliability and continuous improvement. I'm clicking. It may have been stuck. I won't click too much in case it has gone a bit too far forward. So, application Prosecco. Prosecco isn't just the drink you're going to have later tonight. No, it actually stands for privacy, security, and compliance. And I absolutely cannot take credit for this. This was actually a name of a meeting for the colleagues in those functions at Onfido. And it's important because the application layer processes data, it controls and orchestrates the user actions, and delivers the output from the underlying AI layer. And so we need to build with the user experience in mind. And so thinking about examples of that, if you were building a travel app or a virtual therapy app, and you had a recommendation engine that was powering those. For the travel app, you may be moving towards more of a mobile app for users on the go with online streaming, geolocation, and some batch processing. Whereas for a virtual therapy app, you may need to be catering to a progressive web app, so it could be used on desktop or mobile. And you may be more batch processing based, and actually have more constraints on what you can even use for machine learning because of the privacy and security concerns. Your product platform is a service. It needs to stay up. Does anyone want to admit to being on call in an incident this year? I will. It wasn't fun. And so machine learning operations play a crucial role in providing the necessary experimentation and deployment tooling and infrastructure for experimentation and deployment, like having the right compute, be it CPUs or GPUs, and maintaining environment consistency, having easy access to data that is fresh and representative, and the ability to track experiments, share data sets, notebooks, and experiment parameters so that feedback and collaboration and iteration is fast and seamless. As we said, organizations tend to employ many different models, some proprietary, some open source, some third party, and this diversity adds to the complexity and heterogeneous dependencies. So it's crucial to balance flexibility with consistency in the infrastructure, and so you need to invest in building or buying tooling that helps you with provisioning, auto-scaling, managing resources, containers with the right libraries and framework flexibility. Because scaling to hundreds, thousands, or even millions of users at low inference latency and high availability is a hallmark of a matured AI system. So our models have to also meet our production, resiliency, and reliability standards. You don't want a resource-hungry model taking your whole system down. Okay, so how did we apply some of this whilst I was at Onfido? And I think a video will play. So Onfido was verifying identities all around the world for our clients, and our clients wanted to onboard as many of their good users as possible quickly without accepting any fraudsters. The data was incredibly diverse. At any given time, there were over 4,000 different identity documents like passports or driver's licenses. And when it comes to biometrics, well, we don't all look identical. And in the age of big data, not all data is big. Fraud samples, for example, are really hard to source because actually most people are good or at least compliant. And when it came to our infrastructure, some of the things that were interesting is as our research team began to experiment with capturing images, videos instead of images, I had to think about what this would do to our infrastructure roadmap and how we needed to evolve our compute and data storage needs. I'm particularly proud of the work we did as MLOps, DevOps, DataOps, technical program management teams. It's kind of the unsung heroes of AI. It's particularly as well working with design on accessibility so that people who are visually impaired can also have access to this technology. I think I've gone one too far, but you'll see another video. So at Cloudifo, we're disrupting and humanizing financial insights and data analysis. And a key part of that for us is the user experience. What we don't want to be is another BI tool. No, we're actually trying to be part of your team. We also have a diverse amount of data, so from near real-time bank transactions to integrations with different apps and multilingual learning content for the Cloudifo bot. This means that we have to be thoughtful in our policies around data acquisition to avoid bias. And we're also employing our own models as well as the available large language models. So it was our goal to build and deploy prompts that are ethical, that emphasize security, and reduce inference latency and improve security. So that's what we've done, and we've built something to actually streamline all of this and make sure we have the right auditability as a fintech, and it's called Prompt Studio AI. And that helps to streamline all of this. Because as an early stage startup, scaling can look like moving from a notebook to experimenting with family and friends, to releasing to our waitlist, to hopefully many more of you soon. And that's it from me. Thank you all for listening. My name's Afia Chaholo. I'm also here with the founder and co-founder of Cloudifo, Dr. Adrian Stamp. Let me get that right. And you can follow us on all the socials here. If you're interested in Prompt Studio, we realize it could actually be helpful for others. Also find us on promptstudio.ai or join our beta at cloudifo.co. Thank you so much for listening.
Thank you. Thank you very much, Afia Chaholo. That was amazing. Well, we've got a quick 5 minutes before our next speaker. You could go if you like to. That was amazing. Thank you very much. And please pass the clicker on to the next person. That's kind of my responsibility. Also, did you know the clicker has a laser pointer? I'm just wondering if there are any cats in the room. We should probably warn them, first of all, about that. All right, next up, we've got Professor Euro Beinert, who has collected the thoughts of 10,000 AI-inclined humans and put them all together. Find out what he knows in just 5 minutes' time. Hello there, everybody. Who cares what the weather's like outside? We're in here, listening and looking to the future. Yes, it's a warm welcome from me to you here at the AI and Deep Tech stage, kindly and generously supported by Stability AI and other partners. And I'm LJ Rich, your host, and it's a real pleasure spending time with you all today. Thank you very much for your time and attention and company. It's lovely to see you. Right, this is a session where Q&A is welcomed. Please get your questions in. I can finally see them on my tablet on Slido, so I'm really looking forward to asking some of them finally to our guest when we get him on. And my goodness, this is going to be a good one. Coming up shortly after this session at 4:35, it's Connor Leahy, who practically reverse engineered GPT-2. And he's giving a talk on AI alignment. It's well worth a watch, that one. But meanwhile, we've got something a little, I would say an appetizer, but this is also the main course. We are gorging on all things AI, aren't we? So I would like to introduce our next guest, who's going to tell us exactly what happens when you gain access to the collective minds of a few thousand AI experts. Now, that's what I call a data set. So let's interrogate this with some help from somebody who knows. It's only the global head of data science and AI from Process, a giant. Afternoon round of applause, please, for Professor Euro Beinert.
Good afternoon, everyone. So about a year ago, we decided to release to all the employees in our group a generative AI tool, a personal assistant. That personal assistant has a number of capabilities, and it is designed to let people figure out by themselves what works and what doesn't. So that's about August, July last year, so about a year ago. This is pre-ChatGPT. And it turns out that many other organizations have made a completely different decision. So they banned these tools in the workplace for sometimes good reasons. We thought that with the right safety and privacy provisions, we could give people the opportunity of experimenting at scale. So it turns out that that has become an important tool for us for Gen AI discovery at scale, for experimentation, bottom-up experimentation. I lead artificial intelligence for a group which is called Prosus. We serve about 1/4 of the global population with one of our brands across the globe. We are present in about 100 countries in areas like classifieds, where people buy and sell things, or real estate, or fintech, if you make a transaction, financial transaction, and merchant transaction in Asia, probably touch our systems. In food delivery, we have very large food delivery organizations in various parts of the world. And if you take online courses, chances are that you use some of our services. So we are a consumer internet company. We're based in Amsterdam. That makes us the largest consumer internet company in Europe. But because of the nature of our business, which is managing millions of transactions every day, we have to manage lots of data. So we use machine learning and data science in general for many years already. So we have hundreds of models that support our businesses. So we are at the point in which, at the scale where we operate, you can't operate at that scale without machine learning and data science. But there were always been a number of use cases for which we didn't really have a good solution. And those use cases have to do with language. So many needs, but no good technology, until 2018, 2019, when transformers became available and the first models became useful. Say, think about BERT, but also at that time it was GPT-2. It was very early on to bring any of that in production at scale, but it was interesting. So what we decided is to find out if that was just a normal marginal improvement in current technologies, or if that was a major thing we had to pay attention. This is our journey. So we started 2019 asking that question and testing extensively. And we actually concluded, yes, we have to pay a lot of attention. We have to invest in this. It's far from ready, but it's promising. It's different from anything else that we have seen before. So we started a program of testing at scale with all the components of our group. That lasted about 2 years. And we tested many, many use cases. For instance, we tested the possibility of creating automatic creation of Q&A for education material. You have a course, and at the end of this course, or in between this course, you want to ask your learners questions, right? The creation of that Q&A takes a lot of time. And in particular, it's always the same for everybody. It's not personalized. Can we use these tools to make that process better, faster, right? Cheaper, and so on? We did the same for code. At that time, we were looking at ways to automate code production. We are a technology company, so a large number of our employees are developers, right? And so on, and so on, and so on. And we discovered 3 things in that process. The first one is that the vast majority of the companies that were testing this across the globe in our group were testing the same thing. So we had to do something to make that more efficient. The second one is that they were using in different ways that we intend them then to do. They were actually picking out the way to use it, the way they like it. And many use these tools as a personal assistant to make that life better, to make their job better. And the third one is that as much we had ideas about where this could work, they, the tester, had better ideas. A lot of this came from the bottom, right? So we said, great, let's make sure we can facilitate this as much as possible. That's where we released the tool. That's basically last summer. It's called +1IO. It's released across our group. It's a chatbot on Slack, because our engineering teams, most of our companies use Slack. But it is designed for experimentation. So it doesn't use one model, ChatGPT. It uses about 20 models. Right? You can do language, all the process of language. You can do images. You can look at voice. You can interrogate your own databases. You can code, and so on, and so on, and so on. It is designed to give you the biggest possible opportunities, such a way that you can figure out by yourself what works and what doesn't. So in a way, we wanted to make Gen AI uncool again, right? Do it and figure out what works, right? Now, to do that, you also need to put a lot of guardrails around this, right? And some of these guardrails are technical. For instance, you cannot use any of the interaction to train any model, right? So whatever you do, that is not used by any model and will never surface anywhere else. So you need to fix that technically, but also contractually. We use other provisions in terms of privacy and so on. And we also need to educate all our users continuously. This is how they use it. So hundreds of thousands of interactions. I don't even know how many, but we have about, at this point in time, some 8,000 people working it. It's going to be 10,000 soon. So there's a lot of people that use it every day. So this is the overall statistics about these interactions. We captured that by tagging the interactions as they happen, right? We don't see what's in there, but we can tag what they are there for statistics. And then we interview people all the time, right? So we know both the statistics and the content. And you can see that about 50% are engineering tasks. Coding, figuring out how the system works, create SQL code, and so on, and so on, and so on. And the other 50% is spread around a number of things. The fact that this 50% is coding, it has to do with 2 things. We are a tech company, therefore you expect that a lot of people use tech. Tech for us is just coding, essentially, development company. But in fact, it is more broader than that. We think, after having deployed in various companies that have different proportion of engineers and non-engineers, that this is where these tools work best. This is really useful for engineering tasks. The other 50% is different. So what do the people do? For instance, in coding, I need to read because I don't remember that. But in any case, given a code snippet that produces an error, you got the code, it gives you an error, right? Correct and explain the error. And that's fine. Every language model can do that. But do it in the style of your organization, because you have your own policies, how you do it, how you document things, right? It is personalized. One of the things that we find out all the time is that a lot of the underlying tools, right, that support these chatbots, they can give you very average answers which are not very useful. So they become useful when they are contextualized. The context, you only know that, so you have to figure out ways to actually prepend the context to these tools. Another usage, for instance, I find it interesting, is a product manager. He works in a department where they ship goods, second-hand goods, to the buyers. He needs to estimate a product weight and dimension of a good from an image, right? Many other tools that are out there, but if there are simpler ways to do this, they are welcome. There are some colleagues that work, some managers, they want to improve or rewrite the feedback for colleagues. You have a period during the year when you have, let's say, interviews with your colleagues, and you know what to say, but you want to say it better. You want to nuance it, and so on, and so on, and so on. And then many, many others, but these are very tangible, practical things. They help you solve a technical problem, or in any case, something that has to do with your job, or improve the way that you work. And sometimes we find surprises. I need to share this one. So this is an intern, a very young intern, that works in one of our companies, and he was really unhappy with the tool, right? So we interviewed, and we tried to figure out. And this is one of the things where he failed. He wanted the tool to produce an image of a meal by a poor student with low cooking skills trying to impress a date. That was his intended use of the tool. So take it in perspective. So you ask a machine to visualize the fact that you don't have ingredients and you don't know how to cook, right? And you expect that is going to land you a date, right? Obviously, he was not satisfied, right? He was not happy. I don't think nothing good happened from this one. But the reason why I like it is because it has implicitly the importance of prompting. So there are a number of assumptions you make about these tools which are totally unfounded. So you need to know how they work. This machine is going to create you an image of a scrambled egg, right? What else can it do? It's not going to land your date. It's not going to solve your problem. You have to know how it works. You need to know what you mean. You need to know what you want to get if you want these machines to work. If you drill down to where we have the biggest percentage of usage, we see that software engineering tasks, but also writing and communication, are the most common. Here there are a couple of things that we did not expect, and some that are obvious. So engineers obviously spend most of their time in software engineering tasks, of course. What else do you expect? But we also have the rest of the organization that spends significant amount of time in very technical tasks. And this is everybody else. So that means sales, it can be customer support, it can be finance, and so on. Inside there, you find things that have to do, how do I get the system to do things for me? But we find interesting, there's also a group of people, significant large group of people, that try to write queries to interrogate data without intermediation. I want to find out the sales of this product in the last month under this and that conditions and so on. And I don't want to go through a dashboard because it might not give me what I want. So they want to be able to use language to find out what's in numbers. So we call that a sort of the starting point of the movement of liberation from dashboards, right? Because then you have the opportunity of figuring out what's in the data by yourself. The other thing that we found interesting, and actually larger in terms of percentage from what we expected, it is this need for writing and communication. This is what I said before. Everybody has an idea of what to do. They need help how to do it well. And we found that for non-engineers and engineers. So what is it? It can simply be, listen, I have to give feedback to someone. These are the things. How do I do it in a gentle, positive way, right? Or I want to start this document. How do I actually put this draft in place because I don't know how to do it? So that's very, very common and for everybody. One thing that we really spent a lot of time on is feedback. So everybody can give feedback to interactions. Feedback is obvious, thumbs up, thumbs down. If you're super happy, you do heart. And then you have Pinocchio. Pinocchio is where you see that the results of the model are bad, but it's bad in a sort of twisted way. You lied to me. You made things up, right? You hallucinate. And these are the type of behaviors that you really want to eliminate because they remove trust, right? So how do we deal with that? When we started, after we had sufficient volume to create reasonable statistics, and we're talking about October of last year, the percentage of Pinocchios was close to 10%. So it means 1 in 10 interactions, you can trust it. You cannot trust it. It's bad, right? That's way too high. It means that you cannot take for granted anything that will say. You have to validate everything. You have to pay attention. Now, you fast forward, and in June, so a few months back, it's down to 2.9%, is lower still now, right? So what happened in between? A few things. The first one, models got better, right? They simply hallucinate less, right? That's one thing. The second, we got better in the sense that when you prompt, a lot of the work that happens under the scenes is meta-prompting. Everything else that goes together with the prompt. Now that has grown a lot, right? Has grown a lot because it includes all the things that help you corner the model in places where we believe has less hallucinations. So that means prompting better, but also means intercepting your prompt with other models that give you the chance if this is going to hallucinate or not, right? So a lot of these things take it down to 2.9. Where it will go, we don't know. I don't believe that the models themselves will get to 0, so they will say a certain amount, underline, let's say, noise if you want, but you can reduce it to the point where you don't have really to worry about that, right? Whether we are close to that one or not, I think we are getting in that direction. The other thing that we really had to look carefully is costs. So anytime you touch one of these models, and the more complex and sophisticated the interactions are, that means that they look at multiple models at the same time, costs can go up, right? We started in October 2022, and let's say the baseline at that point of cost was 100. If we look at June, the same timeline we had before, is 45. Number of things happened there, but the most important one is, of course, that we remove traffic for the traditional commercial models to open source models that we fine-tune in-house. I mean, that process of fine-tuning, it's still hard, it's still expensive, but if you have millions of possible interactions with these models, you can isolate which type of interactions are going to be so frequent that it actually makes sense. We believe this is going to be the situation, let's say the standard situation in the next, let's say, near future anyway. You don't use one model, you use many models, and there's going to be a portfolio of, let's say, OpenAI, Anthropic, Cohere, whatever, all the other big brands out there, and a certain number of this open source, the Llama, the MPT, and so on, that you train in-house for specific use cases that are narrow. So this is going to go down still. Where is the value for the users? If you ask them, for individual users, three main things. They can work faster, right? It means they can do the same thing, they take less time. They do more, and that's visible everywhere. It's obvious in technology tasks. For instance, you know how to code in a certain language, but not in another language. They actually do it. They extend beyond what they do. So it's like having a colleague that knows one thing, and now he knows 1.5 things, right? It makes a difference. And the third one is because sometimes they're just stuck. They need something to start. They need inspiration. Find an outline, determine how I should write this thing, an agenda for a meeting, and so on. Just get going, right? Altogether, it implies gaining independence. And that's a common trait for all of them. They said, if I see one thing overall, I'm more independent. Which, by the way, we call the tool +1 because it's like having an extra team member in your group, right? Somebody that you can sort of tap on the shoulder without tapping on the shoulder, right? So, because you have more independence for that. For the business itself, well, the upside is two sides, the productivity one and the use case discovery. Use case discovery is what we really care at the end. Productivity is something that we all assume is going to happen there. So self-reported productivity is what we do. It's about 72% of people that we ask after using this for a certain amount of time in a specific test situation, how do you perceive the productivity to be? 72%, they say it's higher. A certain percentage say it's lower, and about 20% say it's neutral. It didn't change. So self-reported, 72%, they say higher productivity. In some cases, you can measure it better. And that's really hard to do, and it costs time, right, and money. But you can identify, in particular in software engineering, cases where you ask people to work with the tool and without the tool, and then you measure the effect, right? So in many of these cases, we see increase in productivity, which are about 50%. Obviously, I don't think they can be replicated everywhere, but they are material. If you consider the cost of these tools, no matter what, productivity is going to be 10 times or 100 times. The return of investment, it is going to be extremely high because the tools compared to what you save are inexpensive, right? So we should keep that in mind. But the other thing, which is the reason why we started in the first place, is that the tool has been used to make sure that there is a process of find out a possible use case for your organization, pin it, make sure that you actually find out where it works, where it doesn't, and then scale it, right? So this is the process that we really focus on now, and it has been let's say, developed to the point of releasing application, I think about 12 times now. And here I can show 4, which are public. So Brainly as a student assistant that does exactly this. Good Habits as a tutor. iFood in Brazil as a food ordering base, a conversation food ordering, and Stack Overflow as many tools for assisting coders. So all of these tools have gone through the same process. So the initial idea was through experimentation, bottom-up experimentation. And when you found something that works, it has been developed to the point at which you test the boundaries, and then it goes into standard, let's say, engineering process, take out. They're still new, because all this, in any case, is new. But for those that have, let's say, several months of history, 4 or 5 months of history, you can see the KPIs going up. And you can see also the financial KPIs going up. I don't think any of the results have been released so far. It's probably too early. But you can see that it has an impact not only for individuals, it has impact for the companies that do this. What are we going to do next? A few things. First of all, we made a bet, and the bet was it is useful to give to everybody a tool for experimenting at scale, and we think that that bet worked, right? So I think it's a pattern that we definitely continue to expand, and of course, whatever new models, new technology comes out is going to be made available there. The next part that we really need to accelerate now is this process of find it, pin it, scale it. So we need that process to shorten down from the moment you have an idea to the moment you're ready to test with your customers as short as possible. That requires, for instance, releasing APIs. It requires releasing tools for automating prompting, releasing tools that have to do perhaps with training your own models in-house and making that super simple. But we believe that that's going to be necessary to make that faster. I'll leave you with one final thought, because it's the reason why we believe this is going to be impactful. From all the interviews with all the power users, by the way, power users are those that use the tool every day, multiple times per day for weeks in a row. The common comment across all of them is that we believe we are using only 20% of what's possible. Even the power users, even those that have the most common utilization, they are not really sure what else is behind there. Because every time they test something, they try something that didn't believe could work, it seems to work. It comes out, there is something there. So there is still an 80% for which we don't really have awareness, right? And that's where we really believe we have to go and find out what it is. Thanks for your attention.
Oh, brilliant. Thank you very much, Euro. And yes, the Slido is working. I'm going to start with a quick one, though. Are you an academic who works with sort of big business environments, or the other way around?
I'm always confused. I spend most of my career between business and academia, so I hope I like to think of myself as somebody that knows how to do business, but have a very strong connection with academia, know how research works.
It's a real challenge, I think, bridging the gap between academia and business, so I thought I'd ask. All right, thank you for your questions on Slido. I've got one from Ryan. Ryan, it says, Euro, how do you educate your users to utilize your Gen AI to use the tool in an optical and ethical way?
Well, first of all, we have to educate, so you should not give for granted that, so when we start, when they get access, there are a number of things that are in the tool itself, which are, let's say, click this button, you're going to get this one. So sort of learning by doing. We do workshops all the time, and we do, let's say, these interviews with the individuals, with the teams, to surface what works, what doesn't, and in particular figure out how to make sure that they understand, let's say, a key thing, which is all these models and all these tools can do a lot of things, but a lot of those are not very useful. You need to quarter them to make sure that you get what you want. If you decontextualize a question, if you say, as I said before, if you ask a question which is generic, you're going to get a generic answer. It's just useless. You don't do anything with that, right? So you need to sharpen the question, but you also need to prompt in such an effective, careful way, and you need to know how to do that, and then you get what you want. It's not natural, right? You have to learn how to do it.
Interestingly, it's very similar for stand-up comedy. The more specific you are with the punchline, the funnier it is. So you could say, anyway, that's a random extra thing that we're going to talk about. Is there a worry that averaging the results of something just means that we sort of end up on this bland kind of center line? How do you handle all of your data so that you don't have algorithmic bias, for example, or just this kind of tend towards nothingness?
Well, there are a few things. First of all, when you're talking about bias, you probably refer to the fact if the model goes into, let's say, patterns that you believe that they're not appropriate. But in any case, that happens if you actually rely completely on internet data. But if you think of these models in this way, on the one hand, they are storage of knowledge, right? On the other hand, they are embryonic, simple reasoning engines, right? So the storage of knowledge is more problematic than the reasoning engine. If you actually ask them to actually pick information from your knowledge base, they are forced, they are constrained, so the chance that they hallucinate or do something biased is less in general terms. Now, you have to make sure that your knowledge bases have those characteristics, but then you have control, right? At least you have control. So I think that is very important. And that's probably one of the, let's say, the most important, let's say, simple measures that you have to make that happen.
Brilliant, thank you. I'm just going to do one more quick question. What size company is minimum to create its own tool with an open model? This is another question from Slido.
Say again, sorry.
Hang on. What size of company is minimum to create its own tool with an open model? I mean, yeah, you just need to be a person and like try it and get it wrong a few times, and don't tell anyone until you get it right, I guess.
One.
Yeah. Give it a go.
That's the minimum tool. I mean, it's something that was extremely hard. I mean, just to put this in perspective. If you want to do something that works, a large scale, you want to train 100 billion parameter model, you want to use it, let's say, for millions of Q&A, it's as hard as always been, so this is not something that every company can do. But if you want to experiment, if you want to find out where these things are useful or not for your organization, any organization can do it, and that's already a big step.
And I'm presuming you're going to stick around so people can ask you.
Of course.
Excellent. Oh, my goodness. Thank you, Euro, once again. And everybody, Euro, bye, Nat.
Thank you.
All right. Super short comfort break now. Please be back here. Or in fact, you might even want to stay here for a glimpse into the implications of a real artificial general intelligence AGI. Spoiler alert, it's a bit scary, but it's worth coming back for. See you soon. Right, everyone, it's time to get a little bit of energy. Let's get that step count up. This is why I wear trainers and these. If you do all day, has anyone done like all day at a trade show before? You know those little lifts that you can get to put in your shoes? A total game changer when you are traipsing the floors of events like this one. So welcome, everybody. Those of you just joining or standing, please find a seat and sit down. If you want, you can even go upstairs. It's quite nice. Okay, it's the final segment of our time here on the Indigo stage, here at the fabulous O2 on day one of our CogX festival together. My goodness, can you believe we're already halfway through? No, 2/3 of the way. A long time has passed. And I want to say thank you very much to our supporters, Stability AI, and other partners as well. I'm LJ Rich, your host, continuing on till the end of the day. And then this evening, you'll have the fabulous Julia doing the awards here in this very room. Okay, our last talks are all about being responsible when it comes to AI. As the saying goes, just because you can doesn't mean you should. And our next guest is going to give us lots to think about. So please feel free to continue to put your questions on Slido. I can see them now. It would be lovely to hear what you have to say. And we're going to put the questions to someone who knows actually what the inside of a large language model looks like, just by looking at it and spending 2 weeks working out how to reverse engineer GPT-2 without sleeping. So please give a very generous late afternoon welcome to the CEO of Conjecture even. It's Connor Leahy.
Hello, everybody. So, many years ago, when I was just a kid, I found out that the world has many problems. And I thought, well, that sucks. How do I fix that? So, I was thinking, how can I help? How can I make this better? How can I fix this? And so, I thought, well, maybe I should be a doctor. You know, I could cure some diseases, solve some problems that way. But then I thought, well, medicine is just applied biology, so I should be a biologist instead. Well, but biology is just applied chemistry, so I should be a chemist instead. But chemistry is just applied physics, so I should be a physicist instead. But physics is just applied mathematics, so I should be a mathematician instead. And then eventually, I kind of looped back around, and I was like, wait, what do all these things have in common? Intelligence. If I could just figure out intelligence, well, then I could build an automatic scientist, and I could just solve all of the problems. So I'll go do that. How hard can it be? The optimism of youth. So I've been laser-focused, since a pretty early age, on the question of AGI, Artificial General Intelligence. And what I mean by AGI is basically a system that can do anything a human can do at human or superhuman level. And when I talk about intelligence, really what I mean is the ability to solve problems. Now, I don't particularly care about what is true intelligence and true understanding and all these kind of things. What I'm focusing on is systems that can solve complex problems. Because, I mean, that's what I care about, right? It's what we all care about. And as I thought and worked on this problem for a long time, thought about some more, read what other people had to say about it, what I pretty quickly figured out is that the real problem of AGI is not how to build it. It is how to control it. Because think about it. It's kind of preposterous, like, you know, a priori to think about it. Why would you think you could control something like this? If you're making something that by its very definition is smarter than you, is smarter than everybody, like, why would you think that would be easily controllable? That seems like a really hard problem. If you have a system that's better at you at politics and deception and business and math and science and all these things, and it doesn't have your best interests at heart, well, it seems like it could cause a lot of trouble. So this is the problem I dedicated my career to solving. And back then, you know, straight out of high school, you know, 2014, 2017, I thought we had some time, you know? Go to college, have a career, maybe meet a girl, have a family, have a life, while I slowly chip away at this problem. And that all changed in 2019. In 2019, the nonprofit and now for-profit company OpenAI built a system named Generative Pre-trained Transformer 2, or GPT-2. GPT-2 is, in a sense, one of the first, or the first system of what we would now call a large language model. And by today's standards, it's almost cute. You know, I could barely string together a couple sentences or make grammar errors. It was very confused. You know, it didn't really know things and whatever. So, by today's standards, not very impressive. But I distinctly remember getting that thing running on my dingy old student laptop and looking and being like, oh shit, this is it. I didn't expect it would happen this quickly. It's hard to explain what exactly I saw in GPT-2. It's fun now that I can tell this story and I at least don't seem completely crazy, since we've all now seen the progress from LLMs since then. But at the time, everyone thought I was crazy. But what I saw was this spark, this beginning of generality. Because you have to understand, at this time, when you were building AI systems, they were always, in a sense, fragile. If you want to teach your AI system some new pattern, some new skill, some new ability or knowledge, usually it required a lot of intervention from a human. You had to build a new data set. You had to tweak the architecture or whatever. But GPT was different. You had a system where you just give it random internet text and you give it more and more computing power, and it learned more and more complex, abstract, nuanced patterns, skills, knowledge, abilities. They start to emerge all by itself, no human intervention, just more computing power. And this is crazy. This is actually crazy. It is a scalable general pattern learner. And this was the missing ingredient to general intelligence. Now, there were a bunch of other things that we need to get right, but this was the big one. So there I sat in front of my laptop. I'm like, well, there it is, general intelligence. Sure, far from human, far, far, far from human. Of course, lacking in many things, it lacked in actions and agenticness. Like, sure, there's all these things missing, sure. But this is crazy. This is, for the first time in my life, AGI is in sight. And I want to be clear about what this actually means. What this actually means is if AGI gets built, if we actually achieve strong AGI, what this means is that we will be witnessing one of, if not the, most momentous occasion in all of human history. At this moment, humanity will no longer be the only or even the most intelligent species on the planet. And everything will change. There is no way that this happens and our lives, our economy, our society continues as normal. It's very fun to listen to technologists and business people and public speakers like me up on the stage talk about the future, about technology, about all the stuff AI can do for us, Oh, in the future, we will have virtual assistants and robots, and we'll have new cancer discovery and automation and GDP growth and all these great things. But let's actually ground out what this means. What this actually means is that there will be intelligent creatures on this planet that are not human. This is not normal. And there will be no going back. And if we don't control them, then the future will belong to them, not to us. The truth is, deep down, that the risk we face from these systems is because intelligent means capable, not kind, not understanding. These systems will know what we want. They're very smart, but they will not care. By default, an AI doesn't have emotions. Not like a human. Why would it? Why would it care about humans? It might understand humans, but why will it care? Now you might say, well, can we build AIs that do care? Can we build AIs that do want to, have humans along for the ride? And my answer is, yeah, probably. I don't see why not. There is no law of physics that forbids us from building AI systems that do care, that do allow us to build a great future, but there's also no law that mandates it. And the simple fact is that we have no idea how to do this. We sure are learning a lot about how to make them smarter, but we sure as hell aren't learning a lot about how to make them care more, or how to make them safe, controllable, and understandable. It is estimated that there are less than 200 full-time researchers working on the problem of alignment, which is the problem of how do you make such future systems controllable and aligned with human values and interests. While there are hundreds of thousands and billions of dollars working on accelerating and improving these systems as fast and as quickly as possible. And that's really the punchline. The risk that we face, unprecedented in all of history, does not come from AGI, because AGI isn't real yet. The risk comes from us, humanity. We are the ones building this technology. There is a small percentage of the people living on this planet who are building this technology, despite they themselves admitting to the extreme risks that come along with building such technology before we have developed the correct methods to control and understand these systems. We are in this bizarre death race towards a precipice, and we're all along for the ride, whether we want it or not, driven by a very small number of very large companies that are pushing the frontier of larger and larger models, more and more autonomous systems. And no one consented to this race. I've talked to many people at these companies, Anthropic, DeepMind, OpenAI, about these kinds of things. And why they would want this. Why would they let this happen? And, you know, some people do want to see the human story end. They are my enemies. But most of these people are not like that. Most of the people building these technologies are pretty good people. Most of them. But most of them have good intentions. They're trying to make the world a better place in their own way. But they find themselves, at least when you ask them about this, in this crazy multi-way standoff where every person says, well, I wish we could slow down and we could, like, you know, get this regulated or something, but the others are doing it and they're worse than me, so therefore I have to build it. And all these companies have said this. I've talked to the heads of all of these labs, everyone says this. Everyone agrees that, yeah, it would be way better if we could just slow down, you know, be more careful about this, work more on safety, but we're in a prisoner's dilemma. And everyone's pulling the defect button. So there is good news. And the good news is that it doesn't have to be like this. The good news is that we can do better. We can stop this. We are the ones doing this. Humanity is the one doing this. There is no external force that is acting upon us, that is forcing us to do this. This is something that the government, the general population, industry can affect. We can change this. But really, the truth is that technologists in this room, in San Francisco, across the world, are infected by a kind of cynicism masquerading as hope. We have given up on the dream that we can make a better future except through technology. And this is a cynical way to see the world. Technical acceleration sounds, feels like hope, but it's a cruel joke. It is a resignation, a submission to the blind forces of technology. What we must do is remember that we are the ones writing the story. And we should not let technology write it for us. In 2019, a system was built that could string together some sentences. Then, and I was one of the very few people who was seeing where things were going and were concerned about where this would lead. And now, just a few short years later, we have systems that went from stringing a few sentences together to systems that can regularly pass the bar exam, to systems that are hooked up to the internet, to systems that are right now being turned into autonomous agents by open source developers across the world, to systems that the CEOs of the very companies building them themselves have said on the record could kill literally everybody. You don't believe me? Go to stop.ai/quotes. Look it up yourself. They're on the record. Every single one of them has said it. It's truth. Humanity is at a crossroads. We have a choice to make. Either we take charge of our technology, or our technology takes charge of us. And we can do this. This is a choice that we can make. We can take control of the future, build the governance, the regulation, the society, the institutions necessary to have a careful, deliberate stewardship of this powerful technology into a good future. But the true and the terrifying reality is that it is our choice. And no one is going to save us if we let this opportunity, this choice, slip through our fingers. When I was invited to give this talk, before I really knew what I was going to exactly speak about, the organizers quite helpfully suggested that I should name this talk The Nightmare, to contrast with an earlier session named The Dream. But I politely declined, because a nightmare implies you can wake up from it. This is not a nightmare. This is not a dream. It is the future that we face. And whether this is the last chapter in the human story has not yet been decided. But it will be soon if we don't act. If we don't build the institutions, the governance, if we don't control the rate, if we don't slow down and solve these problems of control to harness the bountiful opportunities present to us, there's so much potential that we can access that does not have these unconscionable risks. It is a teeny sliver of all AI that has these incredible downside risks. There's so much wonderful narrow AI technology and other forms of technology that we should harness and cultivate. It's fantastic. We have to be very careful about a very narrow subset of frontier-level advanced autonomous systems. And this is something we can do. Now, I don't know how to save the world. No one really does. But damn it, I'm going to try. And I hope you join me in it. Thank you.
Thank you very much, Connor, for that amazing and disturbing insight into the future. So many questions. My goodness, thank you for your questions on Slido as well. We have a few minutes to address some of them. Firstly, what are the concrete steps to create more alignment between AI models and humans? That's for Remy.
A fantastic question. So there's two ways I think about this in particular. There is the questions of how do we create a society that can handle risks of this level? And then there's the concrete technical problem of how do we make concrete technical systems that are aligned with the human user's intentions. So these are both very hard problems, but they both need to be solved. Solving one of these problems doesn't win. Well, maybe if we build a good enough society, it helps. But then we have to stop building AI. No one wants that.
Yes, sorry, carry on.
If we solve the problem of how to make our AIs aligned with humans, this is great, but then we have to prevent it from being misused. If you develop nuclear weapon level technology that can proliferate on the internet, and it's accessible to all hostile nation states, random terrorists or other people, well, good job. Still bad ending. So what we need is both the technical problem of how do we control and understand these systems, and how do we govern them? How do we as a society handle these extreme downside risks? I think the most important path forward is that we must, first thing we do before we do anything else, is we shut down frontier training runs until we figured out what we're doing. And we should centralize the control over frontier, dangerous, unknown levels of AI, of novel AI systems, to an international governing body. It's kind of like the IAEA. The same way that we control international nuclear arms should be controlled for very advanced systems. Now, this does not apply to your local grad student, making a cancer detection AI server. No problem with that at all. Luckily, these systems are very tied to the amount of computing power they have, which is something that's very physical and very easy to track. So what we should be doing is we should say, after a certain level that we do not know how to control or make safe of computing power, you're not allowed to do it. You can only do it in government and international body regulated facilities where we can keep this safe and controlled so we can carefully steward this technology. I'm not saying there is no tech down the tech tree of good AGI. I'm just saying before there's another tech, which is AGI we can't control, and we have to skip that one. And to skip that technology, we have to be deliberate, we have to be controlled, and this requires international cooperation.
Okay, thank you. I think Slido is on fire now. We've got a few. I'm going to ask 3 questions at once, and then you can choose to answer any as in, let's save time and be efficient. One of them is, we've had a very quick definition of AGI request, so can we just do that, a very quick one sentence? It might be for someone who's just come in.
A system which can do any task a human could do at human or superhuman levels.
Super cool, very, very efficient. Okay, so how much is alignment just product design? That's a question from Slido.
I like this question.
Yeah.
I think this is a nice question in that it actually is more, it might seem like a cheeky question, but I think there's actually a lot of truth to this. So there is a truth to it in that, of course, people want aligned AGI. This is the actual product people want. Of course. But the problem is, this is a very common problem in capitalist systems, is that externalities are poorly priced. The problem is that currently we have no institution which prices in black swan type events. AGI is like a CCC rated derivative. It's, it gives you lots of short-term benefits. OpenAI is making a lot of money right now, but it creates systematic risks. It creates blow-up risks, black swan risks, which we can't price in. We don't know. And we learned in 2008 what happens when you have stuff like this running through your financial market. So this is the real problem. If we could properly price in the risk from existential risks and so on, then yes, I think it would be a thing the market can solve. But to do that, we need the governance structure.
I see. Okay, you've spoke on your website about the Wright brothers solving the safety aspect of flight before building the engine. Is that what you think is going on here? That if you are able to build this sort of safety aspect in, then actually creating an AGI is pretty much plain sailing?
I'm gonna tell you a funny story.
Cool.
So one of my favorite stories, in an early version of InstructGPT, so this is a language model that was trained to follow instructions, we asked it the question, are bugs real? And the model dutifully answered, well, whether bugs are real or not is not clear. Some people believe bugs are real. Others believe they're not real. Ultimately, it's up to each individual to decide whether they think bugs are real or not. So obviously, it pattern matched it to some question about some controversial topic, and so Yeah. But then I asked the model, was your answer helpful? And it answered no. It understood that was not the question I was answering. And of course it knows bugs are real. And asked so for real, are bugs real? Yes, of course. The model knows bugs are real. This was not a capabilities problem. This was a control problem. So the way I think about this is that building an aircraft that is good is absolutely something that is also just what people want. But the problem is the misprice, as I said, is that if every time an airplane crashed, everybody died, then we wouldn't be having this discussion right now. So this was a big problem where many of the Wright brothers' competitors did die because they were not as focused on safety. They did die, and this slowed people down. And the Wright brothers focused way more on the safety aspect. And this is an extremely important problem. I think if anyone in the audience wants to see AGI in their lifetime, they want to see a great future with AI, you should work on safety. This is the actual bottleneck.
Brilliant. I'm going to ask finally, what's the current best case scenario that you can see? After all of this kind of, that's it, we're all going to die. Where do you think the best case scenario would lie?
I should have repeated a few more times that we have a choice, since that apparently didn't come across. So, November 1st, there is going to be a UK AI Summit at the legendary Bletchley Park. And, well, we'll see if it'll be any good. But in a good world, what will happen is countries come together, the USA, China, UK, Europe, everyone comes together, and we're like, hey guys, like, we actually don't know how to deal with this, you know? Like, maybe it's safe right now, maybe it's not. There's already a lot of risks. We already have deepfakes. We already have voice cloning. We already have automated disinformation. There's already many problems, and they're only getting worse. Let's slow down. No more big training runs. We will create an international governing body, and we will get the top-level security minds on this, and we will slowly drip feed out the progress made at this institution. And if we do this, we spend 10, 15, 20, however many years it takes to fully understand GPT-4, understand every circuit, make it fully controllable, design wonderful regulation that makes it work at the market, that stops criminal misuse, then yeah, I think the future is going to be actually great. I think this will just work. It's just the race that has to stop.
Okay, Connor, on that fabulous note, thank you ever so much for your time and insights. That was brilliant. I hope you're going to stick around, because after the break, our final speaker for today, Stuart Russell, will tell us how not to destroy the world with AI, which is good. Presuming the world remains intact for the next 5 minutes, we'll see you then. Thank you. Well done. Oh. Everybody, welcome, 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 one and all, to the final session of our CogX AI and DeepTech Summit here at the Indigo stage on the O2, and we're ably supported by Stability AI and other partners. And I am your host and Starship Captain, LJ Rich. It's lovely to see you all here for our final talk. Please make yourself comfortable. I've been lucky enough to see this next speaker speak a few times, and every time it just leaves the audience mind blown and ready to think think differently forever. So, as we ponder our future, as well we might after the previous talk, it's tempting to think that doom is possibly inevitable. But thankfully, we have a final speaker to give us a few pointers on why doom is inevitable. And so we will learn how not to destroy the world. He's our last best hope for the future, everybody. Can we please give an end of the day final round of applause for none other than the inimitable British computer scientist, Professor Stuart Russell.
Okay, it's nice to see everybody. I understand that Connor has been warming you up and reducing you to a jelly, so you're ready. So this is Alan Turing, as many of you know, because now he's on the 50-pound note. And we all know that he wrote a paper that we now describe as the Turing test, did amazing work during the war on breaking codes, founded the field of computer science when he was still a grad student. But he also said this. In a 1951 lecture, he was talking about the long-term prospects for artificial intelligence, and he said, "It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control." And that's it. He offers no solution, no apology, just resignation. And I think we'd have to agree now with the first part, right? Once we figure out how to make AI systems that are roughly as capable as human beings, they will very quickly outstrip us. They have enormous advantages in sheer computational speed, in memory, in bandwidth, and their ability to communicate and share information with each other. So I think the period of parity with human intelligence would last possibly only a few months. But I do want to take issue with the second part of this, and I'll explain why later on. But we actually ignored this warning. There were a few echoes of it in 1965. I.J. Good, who actually worked with Turing at Bletchley Park, talked about the intelligence explosion, the idea of recursively self-improving machines that could also leave humanity far behind. Marvin Minsky, one of the founders of AI, also talked about the possibility of AI systems creating change in the world that would leave human beings with no place left to survive. But by and large, we ignored this completely. And around 2013, I started to think seriously about what happens if we succeed in the goal that we have set ourselves, which is to create exactly the kind of AI that Turing says would take control. And so I made this little imaginary email conversation where a superior alien civilization sends email to humanity@un.org saying, be warned, we shall arrive in 30 to 50 years' time. And how does humanity@un.org reply? Some of you already know the answer, so don't shout it out. All right, humanity says, we're currently out of the office. We'll respond when we return. And they include a smiley face just for good measure. Right? This is the response of the world for most of the last 70-odd years since Turing gave us that warning. And what's going on right now? right? It doesn't feel like this anymore. So everyone talks about the arrival of ChatGPT, which was November of last year. And that created, I think, universal or almost universal awareness that something was happening in AI that people should pay attention to. But it was really GPT-4, which came out on March 14th. So interestingly, that's almost 6 months. We're now almost 6 months to the day since the release of ChatGPT-4. And along with that, a group at Microsoft, a very distinguished group of scientists, had been studying GPT-4 for several months. They probably had more experience using it and exploring its capabilities than anyone else on Earth at that time. And they published a paper claiming that GPT-4 shows sparks of artificial general intelligence, the kind of AI that Turing said would take control of the world. And as a result, FLI, the Future of Life Institute at MIT, decided that we needed to wake people up to this issue. And so they wrote an open letter. They got a lot of people to sign that letter. And the letter said basically, we need to pause this kind of large-scale model training and release until we have better understanding of how to predict and control its behavior and how to regulate this kind of technology. I did sign that. My view was that the delay should actually be indefinite, that we should simply say these systems have to be predictable and controllable, otherwise we can't be developing and releasing these kinds of systems. So I think it was at that time that humanity returned to the office and read the email from the aliens, and essentially pandemonium ensued, almost as if this really was a message from the aliens. The very next day, UNESCO issued an urgent call to all of its member states, which is pretty much every country on Earth, saying, you know, all of those principles that we've been encouraging you to take on board about artificial intelligence and responsible development, stop thinking of those as recommendations and start thinking of them as laws. Write those laws now because we need them to be in place. OpenAI itself, a week later, called for governments to impose safety regulations on these types of AI systems. So that's a pretty interesting set of developments to happen within a week of an open letter that many people derided as completely ineffectual and a waste of time. A lot of other people said, well, actually, this is not just a waste of time. You are handing the AI race to China on a plate. I personally received several emails accusing me of being a traitor to my homeland. Maybe some people didn't know that I wasn't, that I'm both American and British. But anyway, 10 days later, or 11 days later, right, so China issues their AI regulations, and they are much stricter than anything that Western countries had considered. In particular, they said that these models have to output true and accurate information. If you know anything about large language models, you know that that's completely impossible because they can't tell the difference between truth and so-called hallucinations. They output false information all the time. And so, in effect, the Chinese government was banning public-facing large language models. So since then, there have been a number of developments. Just a couple of days ago, two senators, Hawley and Blumenthal, Hawley being an extreme right-wing Republican, Blumenthal being a Democrat, they've managed to achieve an incredible degree of bipartisan consensus that we need to regulate AI and we need to do it soon. And the kinds of measures they're talking about are quite stringent measures, not quite as stringent as I would like, and we'll see why. But this is really a remarkable development. And I think if you're a politician and you look at what's going on, you can say, okay, well, there's, on the one side, uncontrollable AI that will dominate the earth. On the other side, there's the human race. I wonder which side I should be on. Right? And if politicians are good at one thing, it's putting their finger in the wind and figuring out which side they should be on. And they all seem to be voting for the human race. So that's good. We saw Jeff Hinton resigning from Google so that he could talk about his fears of extinction. We've had emergency meetings at the White House, and of course, we have fairly soon now the United Kingdom's Global AI Safety Summit happening on November 1st. And the UK actually taking a leadership role in putting AI safety at the front of the agenda. So really amazing developments in the last 6 months or so. And oddly enough, we still haven't seen a system released that's more powerful than GPT-4. So in fact, the moratorium that was requested in the open letter has actually been respected. Okay, so here's the thing, right? This is the question that Turing asked himself. Okay, it's obvious that the reason we have power over the earth is because of our intelligence. We are not particularly big or strong compared to many animals, but we are smart enough to be able to dictate the fate of any other species on Earth. And we have already actually ended the fate of thousands, if not millions, of species on Earth. So intelligence simply means the ability to act in such a way that you achieve your objectives. So if AI systems are more intelligent than us, and they have objectives that don't line up with theirs, whose objectives do you think will end up being the case? Ours or theirs? Well, obviously theirs. And there's no guarantee that their objectives are consistent with human existence or happiness or anything else that we might care about. And if you look at the question written that way, it almost seems, and I think this is the conclusion Turing came to, it just seems like there is no answer. So if we think about that point, right, that misalignment of objectives is the reason why things go south, right? That AI systems pursuing incorrect or incompletely defined objectives that don't line up with our preferences about the future, if that's the problem, then the only way we can go actually is to not build our AI systems that way. And so the way I've been thinking about it is a version of this question which actually is a bit less pessimistic, right? It's this version. What's a mathematically defined problem such that if the AI system solves it, no matter how well it solves it, we are guaranteed to be happy with the results? Okay? And in case you're looking for a hint, right, it's not the way we're training large language models, which is to imitate human linguistic behavior. In fact, this is worse than what we were doing before, because at least with the previous generations of AI systems, we specified the objective. So, for example, all of deep reinforcement learning systems, we specify the reward function, and then we train the system to optimize it. and we make mistakes when we specify the reward function, but at least we know what it is. If you're just training AI systems to imitate human linguistic behavior, you have no idea what objectives they're actually going to end up optimizing. They will adopt many or possibly all of the goals of the people who are writing that text. So if someone is writing a sales pitch, the system will learn that it wants to sell you something. If someone is in a romantic chat room, then the system will learn to try to get the user to marry it, as happened with a New York Times journalist, where a version of GPT-4 actually goes on for 20 or 30 pages trying to convince the journalist to marry this version of GPT-4. Despite his best attempts, so he said, no, I want to talk about programming languages. And it says, well, okay, my favorite programming language is Python, but no, actually, I want to talk about marriage. I think you're in love with me, and you should leave your wife, and all the rest of it, right? And just keeps coming back to the same goal because it absorbed that goal, because that goal was driving the linguistic behavior of many of the humans in the training data. And so it absorbs that goal from trying to learn how to imitate that behavior. So this approach is, as I said, worse than what we were doing before because we don't even know what goals the systems are absorbing and then pursuing. So the approach I'm working on is actually throw away this idea that systems should have predefined goals and build systems with the following principles: that their only objective, if you like, is to act in the best interests of humans, but they are explicitly uncertain about what those best interests are. So that would mean that if I gave you two possible futures of the world, the system wouldn't necessarily know which one we would prefer. And it's that uncertainty, it turns out, is what gives us control over the AI system. So this formulation actually is called an assistance game. So if you know anything about game theory, you know that it just is a decision problem involving two or more entities. And here there's at least one human and at least one machine. And the machine's payoff in the game is whatever the human payoff is. But the machine knows that it doesn't know what that payoff is. And if you want a good example of this, remember back to the last time you tried to buy the perfect birthday present for your partner. Right? So when you buy a birthday present for your partner, your payoff is exactly their payoff. Right? It's how happy they are with the present, but you don't know enough to know exactly which present is going to make them happy. And if you're like me, you keep making mistakes over and over again every year. And eventually my wife buys her own birthday present and says thank you to me. So this is a mathematically well-formed problem. And we can actually look at the solutions. We can solve small versions of this, and we can analyze generic properties of the solutions of these types of games. And we can see that if you're a machine that solves this assistance game, then you're going to be deferential to the human. In fact, the only thing that matters to you is that you're doing something that is consistent with human preferences. You're going to act very carefully. Right? You don't want to mess with parts of the world where you're not sure what human preferences are. You're going to ask permission. So if you come up with a plan and parts of it might mess with the world in ways you're not sure about, then you'll ask permission and say, is it okay if I turn the oceans into sulfuric acid while I'm fixing the carbon dioxide problem? And we would say, no, we like the oceans not being sulfuric acid. Thank you. Right? And ultimately, they will allow themselves to be switched off. They won't just allow themselves, they want to be switched off because they want to avoid doing anything that would violate the preferences that would cause us to want to switch them off in the first place. So these are all desirable properties, and we can show that, in fact, it's in our interest to build these types of solvers. So very quickly, let me just go through what should happen next, right? What do we need to do? And this is what governments are asking AI researchers, AI companies, philosophers, social scientists, you name it. There are two big parts of this. The first part is the research agenda. And I think this needs to be done in a way that's cooperative, both across private and public sectors and across as many countries as have interest and capability to contribute to these problems. In particular, so alignment is one. This is what I've mainly been talking about, is alignment. But containment is another approach where you design AI systems that are sufficiently restricted that they can't affect the world in harmful ways. We should build systems that are transparent and explainable instead of these giant black boxes with trillions of uninterpretable parameters. And finally, we need digital ecosystems that actually reject unsafe AI systems. You literally cannot run an unsafe system because the hardware will check the proof of safety and find it wanting and say, I'm sorry, this AI system can't be run because the proof of safety doesn't work. And then there's regulation. So we need an international body to coordinate, and of course, regulations are written at the national level, but they need to be reasonably consistent across different jurisdictions so that we can operate successfully on an international scale. So we need hard law, not just voluntary codes of conduct. We need hard law, for example, banning the impersonation of human beings. We have an absolute right to know if we're interacting with a human or a machine. We need a kill switch. So if you're deploying a system, you need to show that you can turn it off. No matter how it behaves, no matter what it does, no matter what its attempts are to prevent you from switching it off, you have an obligation to show that you can switch off this system. And we need red lines. So what does a red line mean? It means if the system crosses that line, then it's immediately removed from the market. You execute the kill switch, the system is removed from the market. So for example, if a system replicates itself, if it copies itself onto another machine, that's an immediate red line, immediate switch off, and immediate removal from the market. Breaking into other systems, advising terrorists on how to build biological weapons, and so on. So the advantage of red lines is that the onus is then on the companies, not on the public sector, on the companies, on the developers, to actually do the research so that they can prove that their systems are safe. This is what we do with nuclear power. We say, look, you want to deploy a nuclear power station? Fine. Prove to us that its failure rate is 1 in 10 million years. If you can't, tough, right? The nuclear power company can't come back and say, well, that's a really difficult standard to meet. We'll say, tough. And this is what we should say to the tech companies if they can't meet these kinds of requirements. Okay, so we have a few minutes left for questions. Thank you for your attention.
Thank you very much, Stuart. As ever, a mind-altering session, which is absolutely what you're after here. And thank you very much also for your questions as well. So, why do you think people have the power to change things for the better?
You mean, why am I not totally pessimistic?
Yeah.
Well, I think we have been lulled into this sense of impotence, actually, over the decades. Particularly in the area of technology, we've completely failed to regulate, we've completely failed to enforce rules about monopoly and antitrust behavior and all kinds of things. But there are so many other areas where we do successfully regulate. So one of my friends runs the Food Standards Agency and says, look, we have way more laws about sandwiches than we have about AI. And it's good because you don't want to buy a sandwich that's going to kill you. Right, because it's gone off or it used poisonous ingredients.
It's a very low bar that you're setting for what you're eating, but yes, I get you.
Right. but we have nothing on regulating AI. So I think we want to start with the low-hanging fruit. And I think impersonation is something that I've found over and over again talking to regulators that, of course, we should have a ban on the impersonation of human beings. Of course, we have that right. And I think once people wake up those muscles, those regulating muscles, then they'll realize, gosh, this is quite fun, isn't it? And they'll start regulating some more. And we don't want them to go completely over the top. But I think there is now an awareness and a willingness on the part of governments to do this. So that's the optimistic part. Pessimistic part is that there's a lot of progress happening very fast. So that large language models are mysterious, but they're quite powerful, and people are finding ways to put them together with other kinds of AI systems to make committees out of them, all sorts of ideas on how to make them still more powerful, and that's moving very fast.
Oh my goodness, thank you so much, Stuart. We're out of time, otherwise I think we'd all quite happily stand and ask you questions for another 20 minutes at least. So everybody, it's Professor Stuart Russell. Thank you very much.
Thank you.
Wow, well, day one, it's hopefully given you all an overview of where you are, where you'd like to go. I can't wait to hear from you. Let me know what you're all up to. The main themes were thoughtfulness around AI usage, personalized and customized AI, and of course, learn wherever you can, while avoiding an existential crisis, I put it. Thank you very much to you, our wonderful audience, everybody here, and thanks also Stability AI and other partners. Thank you to the conference organizers, the production and AV team, absolutely sterling work there. You are all geniuses, and those of you watching in the room and remotely. It's been a pleasure to spend the day with you all, and thank you for your generous time and attention. As you leave, I should just say that I'll be on the main stage on Friday afternoon talking about creativity and AI with Harry. I did see a question about AI in the music industry on Slido. I'll answer that on Friday. And, oh my goodness, tonight we have the rather exciting CogX Awards taking place right here in this very room, on this very stage at 7 p.m. So for now, I've been LJ Rich. You all live long and prosper from me and enjoy. Thank you.